I'll leave it like that. I've got it turned up max.
Is a GIS manager at Dakota County, where he has worked since 1994. He has been involved in a variety of activities related to implementing the U.S. National Grid. He serves on several committees for Metro GIS and Minnesota Geospatial Advisory Council, including the Emergency Preparedness Committee. He has over 35 years of experience in geographic information science, including cartography, photogrammetry, database design, programming, GIS analysis, and project management. BJ Kolstad became involved with Shared Geo's Emergency Location Marker program in 2010 through her role as the Emergency Management Director for Lake County, Minnesota. Serving for 18 years on the Sheriff's Rescue Squad, she understands the need for accurate geolocation when responding to people in trouble. BJ is not a GIS professional, but a user of US National Grid for incident response. She likes knowing where she is while playing in the woods. Okay, I'm going to hand this off to you two. Take it away, Randy and BJ.
Okay, thanks. Well, this is interesting, doing a virtual conference. I've done a few virtual presentations, but workshops, I've done workshops in the past, and they really intended to be interactive. I encourage you to turn your cameras on if you have one, so we can see that we're at least talking to humans. That would be nice. It adds a personal touch to it. Don't be afraid. And it is a workshop, so hopefully we can be as interactive as possible. Feel free to interrupt. Everybody does have reaction buttons. If you're not familiar with Zoom, down on the bottom of your screen is a little reactions, and you can click on that, and you can put a hand or a clap or a heart or a happy face, whatever you want to do to kind of get our attention if you want to, or if you just feel like engaging in some way. Go ahead and give that a try if you want to. It just stays on for a little while. Also, there is a chat. If you open up chat, you can type something in there. Pay attention to who you're typing it to. It defaults to everyone. And encourage you to chat there. If you want to do a side conversation, that's possible too. But if you have a question or you can't get our attention, just put something in there. We'll try to monitor that and stop and answer the questions. I want this to be interactive. Please engage. You should just be able to unmute and start talking. It does focus on whoever is talking. So, if I don't take a breath, you won't interrupt. So do your best to interrupt. Feel free to interrupt, and encourage you to interrupt. And turn your cameras on, please, if you are able, if you have a camera. It's nice to see people. Thank you, Kyle. Nice to see you. All right. Okay, well, with that, we'll get started. I'm Randy Knippel. I'm the GIS manager at Dakota County. I got involved in this about 10 years ago. I think it was more than 10 years ago, and really got involved in it as a way to open the door with emergency managers and first responders. And it's really part of our challenge in GIS is being able to show potential customers what we can do for them. And so this was a great way to do that, and really been sticking with it and expanding on that since then. So get started. I'm going to do an introduction to the National Grid. This is actually the same presentation that I'm scheduled to give on Thursday. So, if you want to come back and hear it again, you're certainly welcome to, but I intend to give the same presentation then as well. And then BJ will take over and give an emergency manager's emergency response perspective. And then in the third segment, I intend to do a deeper dive on the GIS side. And we'll look at actually how to make maps and what the National Grid is really all about at a technical level. So get started. And this is really a lot of slides that I've given to a variety of audiences over the years, but including first responders and emergency managers. Now, here in this kind of a GIS technical setting, I can highlight some things that are more technical in nature, GIS related, and I'll try to do that along the way. But when I'm talking to the emergency managers and first responders, I stay out of those weeds, and that's really what this is all about. But over time, people have become pretty aware now of what GIS is. And in a lot of ways, they think we can do magic. So, all of the 3D modeling and analysis and things that we can do, people really start to understand that now. But when we think about GIS for emergency management, we really have to think about this emergency management cycle, which is what they're familiar with. And the response phase is after an event when they're trying to preserve human life, and then recovery is when you're trying to bring things back to normal. Mitigation is when you learn from the event and try to minimize the potential impact of such an event in the future. And then preparation is doing whatever you need to do to be in a better position if something like that happens. So in emergency management, in these different phases, GIS can apply. So in the response phase, right after an event, we can get involved in damage assessment, search and rescue. In the recovery phase, helping to track status and helping to track resource deployment. In the mitigation phase, analyzing the things in the community and providing some different scenarios for resolving any of the problems that occurred. And then preparation, planning, tracking the different resources and elements of the community. But what we really have to think about is right at this point, you can see, everybody can see my pointer, I believe. You know what? I'm not sharing my screen, am I? Am I sharing my screen?
No.
Oh my. I'm gonna back up. Oh, here we go. I'm sorry about that. How about now?
Yes, now you are.
All right, so that's all the cool stuff that we can do that I was talking about. And then here are the different phases of emergency management. And it is a cycle. Now you can see the picture, so it goes around in a circle. I'm glad I caught it now. So now everybody can see my pointer, correct? I'm pointing, it moves around kind of slowly. But right at this point, at the beginning of the response phase is when the event occurs. And what we need to think about is what can we do at that point that is most reliable with the least amount of resources, something that we can do very dependably. And we need to think about what happens if we don't have electricity, or what happens if we don't have computers. And so what that comes down to is maps. And it's not just, and these are printed maps. We want to have not many sets of maps, because we know that every time we print a map, it's out of date. But what we need to have is the right amount of maps printed and distributed, so that not only can we use them and provide them, but that emergency responders and emergency managers already have them. And not only do they have them, but they've already received training on how to use them. So we teach them about the basic concepts of map reading and land navigation. So it's very fundamental. In a lot of ways, we take maps for granted. And it's something that really was kind of an eye opener for me as I was able to get out and be an observer on some of these emergency response exercises, which you are able to do if you are invited to do so. They would be talking about the scenario and how they were deploying resources, and they're all gathered around a table in a mobile command vehicle, and there are no maps. And it was really shocking for me. And so we really help them understand what a map can do for them, helps them relate locations, and really provide a visual a visual representation of the event. So it's all about teaching them the basic skills of how to use a map. And then we also pre-build these maps so that they're available in an emergency situation with a minimum amount of resources. And that's really what this is all about. I've really focused on two different sets of maps. The large maps are 1 to 24,000 scale, 22 by 24 inches. The smaller maps are 8.5 by 11, 1 to 6,000 scale, 1 inch equals 500 feet. And those two work really well, and you'll see those throughout. And so just teaching them basic concepts of how to use a map. So we teach them to pay attention to the grid numbers. I mean, we put grids on the maps, and we teach them that if you want to talk about a specific area or location on the map, you use those numbers and you read right and then read up. And so a given grid square is going to be called 7556 in this case, reading right to 75 and up to 56. The grid square is referenced using the lower left corner. And then we also then provide these smaller scale maps, or larger scale maps, I'm sorry, 8.5 by 11. And if you want more detail, you simply refer to those maps. And so where the larger maps have 1=2,000 feet, 1:24,000 scale, you know, at that scale, we can show schools and churches and fire stations and police stations and things like that. But on the larger scale maps, now we can get down to actually showing buildings, addresses, fire hydrants, street names, and all of that. And so the two map sets really complement each other very well. If you want to find a page in a book for grid square 7456, well, there's a page numbered 7456. And you're able to simply go to that page and then see all of that detail. In the same way, when you're on the detailed page, if you want to describe a smaller area on that page, you simply add another digit to that. So now again, reading right to 1 up to 5, this grid square is called 741565. So with 6 digits, we've described this square on a page. And all of those maps are come in the form of map books. So we can very easily create a map index. In this case, it's for the city of Burnsville. It's very easy to pull out all of the pages. These are all created as PDF files. They can very easily be pulled together into a multi-page PDF file so that all the pages that a given jurisdiction needs are in that map book. Now, I said I got involved with this to really open the door with emergency managers and first responders. This really happened. It was really driven by our fire chiefs in Dakota County. You know, I've been trying to work with emergency managers and the first responders, fire chiefs, police chiefs, and help them understand what GIS was and what kind of data we had in GIS in the database. And I had given a presentation to our fire chiefs talking about all of this stuff. And I got a call a few days later, and one of the fire chiefs called me, and he said, you know, we've got map books for our city, and our neighboring cities have map books, and we kind of like our map books, but when we get called out for mutual aid to go to our neighboring city, we really need to see their map books. And you know, their map books don't look like our map books. Can't we just have map books that are consistent across the entire county? And it was really very humbling for me to realize, with all the technology that we hadn't realized that something that was really pretty basic, elemental for us, was something that was essential for them. And so that's what really got the whole thing started. So we created map books for all of our cities, and then all the map books are consistent. They're all PDF files, so we can very easily update them and provide updates. Anybody can print an 8.5 by 11 map. They can print pages at home if they need to. Okay, then again, getting back to the grid numbers. So now when we're on a page, it's pretty easy within a given grid to estimate, breaking that into rows of 10 and columns of 10. So by adding one more digit, we can estimate a location on that map and call it 7413565. So again, reading right, then up, we can then estimate over about 3 and up about 8. Now, these are all in meters. So what we've actually done is identify a location to a precision of 10 meters, and we can reference that as 74135658. And so it's very easy then to see which page we're on, because the first two digits, 7456, get me to that page. And on the larger map, it's going to be 75. So all of this works together very logically. It's very easy to teach, and it's very useful once they get familiar with it. Well, this is all part of a national system. You know, I told the story about the fire chiefs and the map books. And at the time, of course, that's a very easy thing for us to do, create maps across the entire county. You know, if you're familiar with ArcMap and data-driven pages, ArcGIS Pro has map series. It's really easy once you set up the template and set up the areas that you want for the maps to just create all the maps automatically. But I needed to have some kind of a map page system. And I realized that the U.S. National Grid really helped us with that. So the nice thing is that it's part of a national system. And so what you can see is that there's a logical naming system across the entire country. We'll go into more detail on that, but this is the U.S. National Grid. So really, when I'm giving this kind of a presentation to first responders, emergency managers, I don't even say U.S. National Grid until this slide. So take them through that process. And I embellished a little bit with some of the technical detail for your benefit, but I stay out of the weeds and just help them understand this is very easy. It's about basic map reading and land navigation. But this is a U.S. National Grid. The U.S. National Grid has been a national standard since 2001. It's been adopted by several federal agencies, the Federal Emergency Management Agency, Department of Homeland Security, National Geospatial Intelligence Agency, and the United States Geological Survey. The significance of this is that FEMA and DHS are on the emergency management side of the federal government, and the NGA and USGS are on the mapping or geospatial side of the federal government. So both sides of that equation have adopted this as a standard. It's also been adopted by several states. I list a few there. It was adopted by Minnesota as a standard in 2009. Every state should do the same. Adopt whatever mechanisms you have in Wisconsin for adopting standards. The U.S. National Grid should be adopted as a standard. Effectively, it is through FEMA. Now, the U.S. National Grid is, in effect, it is actually the military grid referencing system. So this is nothing new. The military grid referencing system has been around since World War II. It's been proven in the military. It continues to be used in the military. This means that when we make maps and when we train first responders at the local level to use this system, they will be directly interoperable with the National Guard. And all NATO forces use this worldwide. So it's not just a national system, it works worldwide. And in fact, it's nothing more than a convenient notation system for UTM coordinates. So UTM has been around for a very long time. So this is nothing new. People get a little scared about talking about this grid system, and it's got letters and numbers and it looks kind of strange, but it works. And there are good reasons for the way that it's been designed. But just remember that these are UTM coordinates. It's nothing new. And so really what's happened is this is a way to present some very complex geospatial concepts about how to map the surface of the earth accurately and present it in a way that's uniform for everybody and easy to use. So that's what this is all about. And if we look at the USGS maps, the US Topo series, they used to make the quad maps. These are based on quarter quadrangles, but that's why we see the UTM coordinates with this kind of notation, where you have the superscripts for certain digits, and you have the larger digits for the ones that are significant for labeling the grids. That is a grid reference. 6981 is going to be that grid intersection. And in fact, it describes a square. And then the other elements that make a map US National Grid compliant, we can see the little text boxes that describe the grid zone designation in the 100,000 meter square. And then there is always this grid zone designation box. So same kind of convention that is used by the USGS. So let's look at this a little bit closer. So here, what we're actually showing are all of the grid zone designations and 100,000 meter squares. So let's look at that a little more detail. First of all, what you can see, the grid zones are 6 degree by 8 degree quadrangles. And if you look at this though, we have zone 15U, 15T, 15S, 15R. This is UTM zone 15. And all we've done is break it into 8 degree increments. Then you see all of the smaller boxes in red. Those are even 100,000 meter increments of the UTM coordinate system. And each square is given an alphabetic designation. And I'm not sure if you can see that. You could probably see that. What you'll notice is that there's a column of V all the way up, and then there's rows of M, L, K, or it should do it the other way, A, B, C, D, E, F, G, and so on. So these are rows and columns. They are labeled within each UTM zone, and they don't duplicate in the adjacent zones. So there's some good convention, good reasons for that as a convention. So if we look at VK, for example, and we look at all the other VKs in the US, there are only 4, and they are about 800 miles apart. So VK is not duplicated for 800 miles in any direction. So what this means is that VK is unique for 800 miles in any direction. If we know that we're working in Minnesota and we say VK, we know we don't have to really say 15T anymore. So right away we have a abbreviation of the UTM coordinates. So let's look at this a little bit more. So USNG coordinate format starts out with the grid zone designation. First of all, let's look at this. Is actually, if we were to look at the UTM coordinates, it'd be 15N, 15 north, and then 492,220, 4,976,580. So we always have to provide all of those digits, but by using the grid zone, you can see it's zone UTM zone 15 and then grid zone T. VK is the 100,000 meter square. And so when you see the rest of this now, easting and northing, or right and up, that's the numeric portion at a precision of 10,000 meters, okay? And so the first thing that this does is give us an even number of digits in X and Y. It really takes away these very large numbers that are really not significant at a local level. We know the area that we're working in. Why do we always have to say 4,900,000 and then whatever follows that? So it's really a way to abbreviate very quickly. 15TVK gives us that very large area context, but once we know we're there, we only need to work with the numeric portion. So right away, that's the benefit. And so the meters are always going to be in the range of 0 to 9999. So let's just look at that. So 15T is a 6 degree by 8 degree grid zone. VK is the 100,000 meter square, and that's an even 100,000 meter increment of UTM coordinates. The first digits then is going to take us down to another level of precision. So now we're at a 10,000 meter square, and even 10,000 meters of UTM coordinates. If we add another digit, now we're at a 1,000 meter square. And add another digit, we're at a 100 meter square. Another digit, we're at a 10 meter square. So what that means is that we can choose the number of digits that are appropriate for the given scenario. It also, conversely, if you have a location to 10 meters of precision or 1 meter of precision. It's also very easy to be able to scale that up to a larger area simply by dropping digits to the right. So a little bit more about precision and truncation. We can look at a full US National Grid designation. The US National Grid allows spaces. MGRS does not by convention or by standard, but I think a lot of people do that just for readability. You can insert spaces in a US National Grid grid reference. Full precision to 1 meter is going to be the full 15 characters, but we can start to get some efficiencies here. If we know that we're in grid zone 18S, we don't need to say that over and over and over again. We can simply refer to UJ 2306. And in that case, UJ is the 100,000 meters squared. 2306, simply because there are only 4 digits, we just know by convention that's a 1,000 meter square. And in the same way, we could eliminate the 100,000 meter square if we know that that's everything we're doing is within that 100,000 meter square. And now by simply using the digits and 4 digits in X and Y, we have 10 meters of precision, assuming the grid zone designation in the 100,000 meter square. So we can pick and choose the level of precision that's necessary. If you're trying to direct a helicopter to a football field, 100,000 meters is probably sufficient. So why do we need this? Well, it really gives us a convenient way to design map pages and to be able to have the different sets of maps and be able to teach land navigation and map reading. But we really need to think about it for this kind of a scenario where we've lost all visual cues in the field. There are no street signs. We can't even tell where the streets were. We can't tell where buildings were. But we may want to know, for search and rescue, where was that daycare or where was the pharmacy? We may have to go and recover some materials or something like that. And how do we track our efforts when we're out there in this debris field, sending resources out there? And how do we keep track of which areas have been cleared and which haven't? Well, the grid basically gives us an overlay for this kind of a debris field. And using GPS now, we can navigate to a given location. We can be aware of some kind of a spatial coverage of that area, 100 or 10 meter squares or 100 meter squares, and be able to designate which squares we've already searched, for example. And everyone gets a unique name. So it's very easy to track this stuff over time. And then using GPS receivers will all have a setting for either US National Grid, USNG, or MGRS. You'll always find MGRS because the military uses GPS, of course. And then not only knowing where they are, but having maps that represent those areas, as well as maps that show how things were before this event occurred. So showing the key resources, critical infrastructure, vulnerable population in our communities on the maps allows them to navigate using those maps to given locations. And then to be able to very easily and unambiguously relay those locations over a radio and things like that. And that's really why the military developed it. They needed to be able to have a convenient and unambiguous way of relaying locations from forward observation posts back to artillery firing stations, so that they would be able to locate very precisely the targets on the ground. And there are a lot of parallels, of course, between emergency response and the military. And so then teaching them how to read the maps. And then the maps, when we start to map things like the extent of the damage or the status of search and rescue operations, we can provide situational overlays on the same maps that they're already using. So we don't create any confusion with introducing maps that they haven't seen before. We train them on the use of the maps, and then we provide the same maps during the event to show the new information as the event unfolds. So what about lat long? This is a question that always comes up. Why don't we just use lat long? That's on GPS too. Well, there's some good reasons. First of all, it's not intuitive. It's a base 60 system. There are 360 degrees around the world. There are 60 minutes in a degree. There are 60 seconds in a minute. It's a base 60 system. We don't really think in those kinds of terms. We always have to make the conversions and think about that. There are also several formats for lat long. We can describe it as degrees, minutes, seconds. We can describe it as degrees, minutes, and decimal minutes, degrees and decimal degrees. It's very important to know which one we're using. And if we don't do it correctly with the degree symbols and the double ticks and the single tick and so on, it can create a very large amount of confusion on the part of somebody trying to interpret those locations. And there are stories out there of how that has happened, where somebody related as degrees, decimal degrees, and somebody interpreted it as degrees, minutes, seconds, or degrees, minutes, decimal minutes, and you end up 50 miles away from where you're supposed to be. So that can be a real problem. Plus, when we're talking about longitude, we can express a longitude location as a positive number or a negative number, either east or west of the prime meridian. Or we can say it's a west longitude or an east longitude. Well, if we describe it as a west longitude or a negative number, the numbers themselves actually increase from right to left, which can be really confusing. So finally, how big is a degree? Well, the Earth is round. That means that the size of a degree can vary. At the equator, a degree of longitude and degree of latitude is approximately 69 miles. Well, at our latitude in Dakota County, same as Wisconsin, a degree of longitude is about 50 miles, where a degree of latitude is still approximately 69 miles. So what happens is degrees of longitude actually get smaller as you get towards the pole where they converge. This makes distance calculations very difficult. Now, of course, we can all find the apps that'll give us the distance between two locations in lat long, of course, but you can't really visualize it very well. And I'm sure some people can do it longhand or with a calculator if they need to, but it's still difficult. So if you think about it at a local level, the other point is how many, if you're doing it as degrees, minutes, seconds, or degrees, minutes, decimal minutes, how many decimal places do you need to describe the location to a sufficient level of precision to get somebody there? You know, if you're only doing it to point to one decimal point in minutes, it's not going to get you very close. 10 meters is about half of a second in longitude at 45 degrees, and about 0.3 seconds of latitude. So, you know, if you don't know that, you may not be providing enough digits to get somebody there. Well, when we're working with the U.S. National Grid, we're working in meters all the time. And this is because we're working with a Mercator projection. So again, applying something that's really complex, that we understand about how to map and measure on the surface of the Earth and present that, is done in a consistent and very logical fashion by all using the same thing. We all use UTM coordinates. We all use a UTM projection. This is reinforced by the Land Search and Rescue. The National Search and Rescue Committee was created to create standards across multiple federal agencies when they're all involved in search and rescue. And if we look, oops, that's supposed to have some animation there. I'm gonna just point here. If we look, all land search and rescue operations are supposed to use the U.S. National Grid as the primary georeferencing system. But now you notice that they are also supposed to use latitude, longitude as a secondary geolocational system, specifically in the form of degrees, minutes, and decimal minutes, and that's important. Now, if we look at aeronautical search and rescue, there, latitude, longitude is the primary location referencing system, and the U.S. National Grid is secondary. However, the addendum further states that any aeronautical resources that are supporting a ground-based operation will use the location referencing system of the ground operation, which is U.S. National Grid. So this is what they're supposed to be doing. Now, it takes a long time for this kind of stuff to filter down, but it's really hitting home now, and they're becoming familiar with it, simply because it's reinforced by FEMA and a lot of the documentation in the incident command system, and the National Incident Management System all reinforce the use of the U.S. National Grid. So if we look at this in a little more detail, here we're looking at the 1 to 24,000 scale. I didn't mention these are actually based on a 10-kilometer square. So that means that the map extents for this map are aligned with the even 10,000 meter increments of the UTM coordinate system. So that creates a very logical ordering and organization to the maps. But I said we're going to create these maps ahead of time, and it's presented as a map set or a map series, and we teach them how to use these maps. You know, it used to be, and still is in some ways, you know, the emergency manager would give me a call and say, hey, we got this thing and we need a map that goes from here to there, and I need to see this kind of stuff and about this big. And we would go make that map. It'd be a custom map. Well, you know, we need to help them understand that they have all the maps that they need to get started without having me there or without calling me. And so if we think about an area of operation that maybe covers 2 maps. So now we've got 2 maps. We got an area of operation that is really covers both of those maps, or there's overlap between the 2 maps. They already have these maps in the emergency operations center in a drawer, or rolled up in their trunk or something like that. It's very easy to teach them that they can make a wall map by simply trimming that map and taping the 2 together and sticking it up on the wall. And now they can start to draw on that map with a marker or whatever, how they're deploying resources, what is their understanding of the situation, so that now when I show up and I want to start, I need to start creating these situational overlays, or somehow modeling the event and the resources in a GIS database. I can do that from an accurate source. They're already drawing on the maps that I gave them, as opposed to the back of a napkin or on a whiteboard where somebody's just scratching. They're using a precision tool to start to track their understanding of the situation. So that's very helpful. Very easy to take a series of these and just tape them together, and anybody can do it. Doesn't take a GIS professional to be able to make a wall map using these different map series that are already in the drawer. That works very well. Also, all of these maps are available. We created maps for the entire state of Minnesota. We can put them into a web interface so that they're easily accessible. Through an interactive map, you can zoom in, click on a given square, get the PDF file, save it to your local device, or print it, or whatever you want to do. So the maps are available for the entire state. You can also download them all and put them on a thumb drive. So you've got them in an emergency situation. And this is really what everybody needs to do. Don't rely on the internet. We think the internet's ubiquitous and it never goes away. Well, that can happen. We can lose power. And maybe I can't print them on my site, but if I have all the maps downloaded, it's pretty easy to give that thumb drive to somebody to take outside of the affected area where they do have power, go to a Kinko's or some other printing service and print the maps that we need. So it doesn't take a GIS person to do this once you have that. Plus all of those larger scale maps, the 1 inch equals 500 foot, those are all 8.5 by 11. They're all out there as PDF files, and then we can organize them into map books so that Apple Valley Fire Chief can go to the website, go click on Apple Valley, and get the Apple Valley map book as an entire multi-page PDF file, and then save that as a PDF on a thumb drive or print as needed. They can also open the multi-page PDF file, go to the page they need, and print just that page. Of course, all of the USGS topo maps are US National Grid compliant. These are the 7.5 by 7.5 minute quadrangle, also referred to as quad maps. These are also 1 to 24,000 scale. These are all GeoPDF files as well, which means they have layering. I didn't mention all of the maps that we've created, the 10K maps and the 1K maps are also GeoPDFs, and they also have layers that you can turn on and off. So it really, by using these PDF files, you really have a mini GIS inside of Adobe Acrobat Reader. And you can, in Acrobat, you can do the annotations and things like that there as well, and highlighting and so on. So really creates a kind of a poor man's GIS by just using these PDF files. Just an example of the layers. So all the PDF maps and map books are downloadable. They can be saved locally. It also means that we can automate the production. So ArcMap data-driven pages, ArcGIS Pro map series, we can just crank out the maps, put them in some kind of a map repository that's web accessible. We can create interactive maps for finding individual pages. We can also use things like Python scripting for putting the pages together into map books, so that when you've done it once and scripted it, you simply create all the updated pages, run your Python script, and all the map books get updated and pushed out to the website. This gives us then map libraries that are transportable, standalone. You can print what you need when you need it, and anybody can do it. So first responders, emergency managers can get started. They can provide direction to people to do what they need to do with these maps, and it doesn't take a GIS expert to do it. Not saying that we don't still have value, but it allows us to, when we engage, we can engage at a totally different level, because now they already know how to use the maps. When we provide situational overlays, they're getting the same maps that they're already familiar with. Anything that they're annotating and tracking on those maps relates directly to, those are precision instruments. They relate directly to what we know, and we can start to model that stuff very accurately. A variety of mobile apps also support the US National Grid. Some of them integrate the camera. Some of them simply provide a grid reference location. Go find your favorite GPS app on your phone and look in the settings. There are going to be a variety of options for the coordinate format, and it'll have either MGRS. A lot of them are starting to have US National Grid now too. So that's really encouraging. But if it doesn't say US National Grid, it'll say Military Grid or MGRS, and they're effectively synonymous. Avenza PDF Maps. I mentioned that we create all our maps as GeoPDFs. There's an app out there called Avenza PDF Maps, and it allows you to import a GeoPDF, and it will show your location using the location referencing on your device. It'll show your location on the map, which is very useful. So that means that now, once you've downloaded a map and stored it on your local device, you don't need the internet connection anymore. You can simply open that PDF file. You don't need the internet to be able to get your location when you're using your mobile device. So that's very useful. And there are options for dropping place marks and things like that. It's free for personal use. There's a small charge for commercial and government use. Another app called FindMe SAR. SAR is search and rescue. It's actually a website that you can go to. It's not an app. So you do need an internet connection to use this, but it's very easy to remember. You go to findmesar.com. You can do this on your local machine as well. And obviously you don't have locations unless you're using an iPad or something right now. But then you have a number of options for how you display your location, and you can see that you can do it in both USNG, same as MGRS, or degrees, minutes, and decimal minutes. Oh no, this is doing, I'm sorry, degrees, minutes, decimal minutes. Oh, that's correct. Emergency location markers, this is another standard. I think BJ is going to go in more detail on this, but it's another standard that lets us designate locations for key things like all of our You Are Here maps that are out trail intersections, and it just shows your U.S. National Grid location to precision of 10 meters. There is an app called, another website app called USNG and it'll actually, you can see in red, it's showing the degree of confidence that you have in your location. So if it's in red, you may not want to rely on it too much. But again, it's showing 8 digits, four digits in X and Y, which gives you a location to a precision of 10 meters. That's going to be just fine for somebody finding you out in the middle of nowhere. And then there is an actual app called USNG App that you can download to your device. And then you don't need the internet connection once it's installed. I'm going to give a plug to Shared Geo here. That's a nonprofit here in Minnesota that was created to really provide support for geospatial support for different projects. And they are a nonprofit, and they are responsible for both of these. My USNG, this was actually created by Esri, but it is there is an effort to hand this off to Shared Geo as well. So they're taking that. Nice thing about my USNG, it also includes a map. That's kind of nice. GISSurfer, this is another application out there. This is free GIS, again, free for personal use. The developer of this, there's a lot, it's a very sophisticated, robust application, internet mapping application, but it also does support the U.S. National Grid and a variety of other coordinate formats, but it does also show the U.S. National Grid all the way down to 10 meters, which is pretty cool. And then it tracks your location, either the center of the map or your cursor location in the lower left corner there, showing you where you are. Always remember that effectively you're talking about a square with the U.S. National Grid. Even in full precision, you're talking about a 1 meter square described by the coordinates of the lower left corner. So whichever number of digits that you're using, it describes the precision of your location, as well as the location itself. You can find more information about the U.S. National Grid from a variety of other sources. It may not even say U.S. National Grid. It may not say MGRS. There's a lot of stuff about backcountry trekkers and hiking and things like that. They're using USGS, TopoQuads, and it simply gives them instructions on how to do grid referencing. It's all the same thing. Stuff out there for prepper sites, as well as military study guides and things like that. All define how you do this grid referencing. Iowa Task Force 1 has created some nice videos. I encourage you to go and explore this. They're out on YouTube, but it's a private YouTube video, so you actually have to go to their website to get to the YouTube video. But you can just do a Google search for Iowa Task Force 1 U.S. National Grid, and you'll find that. And they've got really several different segments on how to use the U.S. National Grid. And in a matter of a few minutes, they're actually doing a pretty good job of giving an overview, certainly enough for first responders to be able to use maps and do grid referencing. I encourage you to explore that. USNGcenter.org. This is a website that was created again by Shared Geo. This is the primary source of information related to the U.S. National Grid, and I encourage you to check that out. From here, you can get to a variety of other sources and different kinds of information. This is all maintained by Shared Geo, and something that we can all contribute to as well. Encourage you to explore that. And specifically, there is a place where you can go to actually get information about how to create USNG Map Books with ArcMap. And so you can download the map book instructions. It'll take you through step by step, including an MXD with the map layout, map templates, so you can create your own map books. I'll go into more detail on this in the third segment of the workshop. It goes through all the details. Also, the NAPSIG. NAPSIG is a National Alliance for Public Safety GIS Professionals. It's another nonprofit, been around for a number of years. They have provided a number of different resources and endorsements of the U.S. National Grid. Encourage you to check that out. And specifically, if you go down their website a little bit, there is a map template for creating USNG Map Books in ArcGIS Pro. And again, I'll touch on this in a little more detail in the third segment, but it does go into a lot more detail, and it does also have make use of tasks in ArcGIS Pro to take you through step by step, which is kind of nice. The U.S. National Grid wiki page, I encourage you to go there. We've updated this, spent a lot of time adding a lot of information to this. I'm involved in a work group that's working on these things nationally, and somebody really took the time to go through the wiki page in detail and update it and provide a lot of linking to some of the other stuff that I already showed you. How am I doing for time? I didn't keep track of when I started. Claire?
This is BJ. I've got about 9:50, Randy.
Yeah.
Whatever you need.
Okay. Don't say that. All right.
You have to quit by noon.
I'm going to tell a story. I didn't keep track. We started at what time? We started at 9?
Yeah.
Okay. All right, good. I'm almost done. I just want to tell a quick story. I've been doing training for emergency managers and first responders, and creating these maps and things like that. And there's a special group in Dakota County, and actually they're involved in multiple jurisdictions, called the Special Operations Team. And these are the elite in the first responder community in Dakota County. They get involved in, the high rope rescues and trench collapse, building collapse, hazardous materials, and things like that. And they have to actually apply and be recommended to become a part of this team, because they go into a lot of specialized training. And so these were it was really key. They also then come from different organizations, so it was key to give them training on the U.S. National Grid. And they're always looking for these kinds of technology. They want to use GIS and GPS and things like that. And so I had given them training on the U.S. National Grid. And there are different techniques that they use for search and rescue. And one of the techniques, and really as a fallback, is a grid search. And they would basically grid up an area using some kind of a method, and then methodically go through the area. And that's now being taught using the U.S. National Grid. So they had been taught about this, and then they actually got in. There was this situation that happened where somebody had wandered away from their home and was missing, and it was the middle of winter. It was very cold out, and there was a search team that was created very quickly, and they went through. There was this park in that neighborhood, and they went through that park, and they were not able to find anybody. And so then the next day, they got law enforcement got involved. They had a canine unit. They had a number of volunteers that were involved, and they went through this park and they were not successful. So then they called the special operations team. Special operations team came out. They had their command vehicle. That's the green square up here. And they were able to ask for a map. They wanted to have a map that they could use with the U.S. National Grid. And they went out to do this grid search, and they said, you know, we don't need to do this grid search. We're just going to go out and we're just going to do what we do, and it'll be okay. And they went out, and the underbrush was so thick with buckthorn and things like that they couldn't stay on a line. They couldn't keep track of which direction they were going. They came back to the command vehicle and said, okay, let's figure it out. They broke out their GPS receivers. They broke out their map, and they set it up so they had a GPS receiver on each side of their search line. They had a line of 10 people separated 10 meters apart, and they were able to go through 100-meter squares methodically, and they were able to simply watch their GPS. And when that digit changed, they knew that they were going into the next 100-meter square. They were also able to stay on a line because the other number shouldn't change as they're moving. So they were able to go through this entire area methodically, and the red represents the areas, the squares, as they completed them. And they were able to call back to the command vehicle, say 881-620 clear, and they could mark that one off, and then they would go to the next one, and so on. They went all the way through, and they finally found the person. Unfortunately, it was a sad situation and ended up being a victim, but they were successful in that search after 2 other attempts, really 3 other attempts had failed. And so that, after that experience, these became my champions in the county, and that was a huge step forward, because I was in other presentations where we were talking about things like implementing emergency location markers and things like that in front of police chiefs. And one time I had my back to the wall trying to explain why we were using the U.S. National Grid. And one of the key players that was at the meeting, that's a member of the search operation team, took over and won the argument for me. I didn't have to say anything. And that's huge. When you get the emergency managers and first responders to become champions of this, it's a win for everybody. And it puts us in a great situation then to do all the cool GIS stuff that we can do. Esri is providing a lot of support for U.S. National Grid. There is a map service out there, feature service that will display a National Grid overlay on your maps. I don't so much like the presentation of it, but it's there. It's kind of nice to plug it into an app. I don't have it on here, but there is now a grid widget for my goodness, help me out, Web App Builder. Web App Builder has a gridding widget, so you can just drag that into your Web App Builder application, and you can turn on the grid display, and it actually does a very nice job of displaying the grid. So momentum is building locally and nationally. You know, Iowa has created the same kind of maps that we have in Minnesota. So they've got the 10K 1 to 24,000 scale and the 1K 1 to 6,000 scale. Florida's done a bunch of stuff. You can see again at the USNGcenter.org. There is an app out there that will show you maps and map books that have been published around the country. This is actually an old screen grab. There are more now, and we're actually working on an application where where anybody that can publish maps and register the maps with the application, so nobody actually has to do anything to make the maps show up there. Hurricane Harvey, this was quite a while ago now, but one thing that was really interesting, this is a website that was created after Hurricane Harvey by the Homeland Infrastructure Foundation level data, Highfield, and represented very prominently there are USNG Map Books and resources. So we're really starting to see the federal government represent the use of U.S. National Grid. So this is kind of a corny slide, but this is really, you know, it was a established as a federal standard. It needs to be adopted at the local level, and ultimately, I'm assuming everybody in the audience here are GIS professionals. We own this. This is on us. You know, it's a great door opener, as I said, to be able to have a reason to go and talk to your emergency manager, talk to the police chiefs and fire chiefs about what you can do. Explain, you know, this US National Grid thing that they're starting to see in their FEMA requirements and things like that, and talk about what we can do to help with that. But ultimately, as geospatial professionals, we got to own this one. We're the ones that need to help people understand why this is important and what we can do to support it. And really everything that we have, all the technology we have supports this very nicely. You know, and what you don't want is to have your emergency manager come and ask you about it. You know, take the step, go knock on the door, build that relationship, and start the process of helping the emergency response community within your jurisdiction understand what this is and what it means and what you can do. So with that, so I nailed them 1 hour, huh? Any questions up to this point? No questions. Okay. Do we want to take a 2-minute break?
This is BJ. I just as soon take a 5-minute break, and people know that they can also put questions in the chat, and we'll be together for the next couple of hours, and we can try to go back and answer them during the presentations or after the presentations as well. So thanks a lot, Randy.
All right,
And
so
unless Claire has things to add, we'll see everyone back here in 5 minutes.
okay.
That sounds good.
This is BJ Colstead. If you're just coming into this presentation, we'll start the second hour in about 2 minutes. Randy, if you're still available, I see a question in the chat that says, is the grid built to 1 meter level across the state of Minnesota? And if so, how did you go about building that? Do you want to take a couple minutes and answer that right now? And apparently Randy has gone to get a cup of coffee or something, so we'll get him back on here when he returns and encourage him to interrupt. Okay, welcome back, everybody. Thanks for sticking with us in this presentation of U.S. National Grid and how it helps emergency managers and emergency response. My name is BJ Colstead, and I'm going to start a PowerPoint presentation. But I want to tell you by way of introduction that, as Claire mentioned, I'm not a GIS professional. I like to use paper maps and compasses and pencils, but I've learned through the years that U.S. National Grid is the way to go for search and rescue. I was on the Sheriff's Rescue Squad and served as a captain for about 6 years and 18 years on the Lake County Sheriff's Search and Rescue Team. And so I learned during that time a little bit about how to find people in the woods if they're injured or lost, and how USNG helps. Claire, let me just jump to you for a minute and see if there's anything that you want to add before we start the presentation.
I don't have any updates right now.
I see there was one question in the chat window. I can bring that up in the third segment, and I can talk about that.
Okay.
About the 1 meter grid.
Yep. Thanks, Randy. All right. So I'm going to share my screen with a presentation. Okay. Give me a heads up if you can see that. Okay. Thank you.
Yes.
So the first thing that I want to do for you is just give you a 40-second video that tells you pretty much everything you need to know about emergency location marker program in Minnesota. It's sponsored by the Sheriff's Office in Cook County, which, if you're familiar with Minnesota, is in the very tip of the arrowhead, pinched between Canada and Lake Superior. And the sheriff and his GIS folks and his search and rescue team got together and presented this short 40-second video about US.
Cook County is a popular outdoor environment. Knowing where you are is essential to your safety and enjoyment. In remote areas, it can be hard to explain where you are in emergency situations. That's why Cook and Lake County are marking some trails with these blue and white location markers. Communicating the U.S. National Grid coordinates helps emergency responders find you quickly if you are lost, ill, or injured during a wilderness outing. In addition to signs on many of the trails, visit USNGApp.org on the web browser of your GPS-enabled smartphone to display the National Grid coordinates of your current location. In an emergency situation, call 911 and give the dispatcher the information from the sign or from your phone. Visit usngcenter.org to learn more.
Okay. So let me tell you a little bit, first of all, about Lake County, Minnesota, where I'm from, and a little bit about...
Hi, I'm Jay McClellan with Ionia County Search and Rescue and Montcalm Ionia Citizen Corps. And this video is about using a map for search and rescue. So I'm going to be talking about parts of a map and the style of map that we use for search and rescue. And I'll spend a lot of time.
Obviously, I still have a website going. we go. Okay, I think we're good. I'm sorry about that. Obviously, I'm not a tech savvy as most of you in the audience. So Lake County, you can see where it is in Minnesota. It's got 3,000 square miles of woods and water, and the vast majority of that is public lands. We're famous for having off-road trails that people come to enjoy, including much of the Superior National Forest and the Boundary Waters Canoe Area Wilderness, the largest wilderness area east of the Mississippi. So my role there is I live in Lake County and I served for 12 years as the Lake County Emergency Manager. And that was during and after the time that I was on the Sheriff's Rescue Squad. And so that's how I became involved in this Emergency Location Marker Program, or ELM program. So I want to start off with a true story about before we had the National Grid system. We got one of our rescue calls was by a gentleman who was hiking on the Superior Hiking Trail. That's a 300-mile trail between Duluth and Canada. And he called 911 because his wife, who was with him, had broken her leg. And so we wanted to go find them and rescue her. So he explained to the dispatcher where he was by location description, like where he was near a lake, where he had started and what lake he was near. So dispatch paged us out and we all went there, and of course there was nobody there. It was not a good description of where he was. So I called him on the phone and told him I would like to get a few more details to help us find him. And he said, I already gave that information to the dispatcher. I'm somewhere between Teddigoose State Park and Canada. And he was a little upset because everyone's upset when they have an emergency situation. So I said to him, well, I understand that, sir, but that's a distance of about 90 miles. And we'd like to narrow it down a little bit. So we did eventually find this person and help him get him and his wife off the trail. But that was one of the first times that I realized we need a common geolocation system that we can all share that is specific enough to help us. So one of the steps that got us started in resolving that was in 2010, when our snowmobile trail groups came to me as emergency manager and asked me if I would help them put up location markers on their trails. They suggested putting up mile markers, which would work fine on a linear trail like the Superior Hiking Trail, but on a trail where you have a lot of intersections like your bike trails in Wisconsin or snowmobile trails, it's difficult to figure out how you would use mile markers and where you would put them and where you start the miles. So one of the first things we wanted to do was to make sure that we got all the trail system groups in the same room so that we could all talk together and make sure that we had a system that everyone agreed upon. We also wanted to make sure that our other jurisdictional partners were there, people that held jurisdiction for search and rescue, which in Minnesota by state law is the sheriff's offices, and also the Minnesota DNR and US Forest Service, who have jurisdiction for search and rescue as well. Also our tribal partners, and of course the clubs, the snowmobile and other trail clubs. So if you're interested in implementing a program, helping your sheriff's office implement a program like this, it's really important to get collaboration amongst all the groups that are involved. Second thing we had to figure out was to select a geolocation format. Now, most of us were completely unaware of US National Grid, but with the help of Shared Geo, which is the nonprofit organization that Randy talked about earlier this morning, we learned that there's already a national and a state of Minnesota standard for search and rescue geolocation, and it is the US National Grid. Some people that we talked with said, why are you having us use a system that we have never heard of? So a quick explanation was helpful to let people know what National Grid is and how it was conceived. It started in 2005 after Hurricane Katrina, when responders came from all around the nation to help survivors. And when they got there, they found out that the different groups used different geolocation formats, and they couldn't use addresses because the roads were gone, the street signs were gone or underwater, a lot of the house numbers were gone. And so to find the survivors, it was very difficult to communicate where they were and how to go help them. So 7 different federal agencies got together and said, we're going to come up with a system that works for all of us. And FEMA adopted it in 2001, I believe, but in 2015, they took the extra step to say that FEMA and all federal agencies will use US National Grid for all parts of disaster response. Everything from damage assessment, as Randy showed in the tornado slides, all the way up to responding for search and rescue. And while it's not required for local jurisdictions or agencies to do that, it is certainly recommended by FEMA so that we're all on the same page. So I know I'm talking now to GIS professionals and you know all this already, but we're going to give a quick review for you about the difference between curved lines of lat long and the straight lines of a grid like US National Grid. And as Randy mentioned, the lines around the globe are obviously all curved, and that's very important to use lat long when you're traveling across the curve of the earth. So it's a global geonavigation system that works for aviation and for maritime travel. But if you're working on a local level, small enough where you know that, where you can imagine that the earth is flat, then we don't have to use that. So reviewing what Randy said very quickly, the reason that we don't use lat long for local response is that it has some challenges. It does come in 3 different formats, which you're all familiar with. The distances between the lines varies. Every time you take a step, the longitude gets narrower as you walk toward the poles. It's a base 60 number system, which of course I don't have 60 fingers, I only have 10. So a base 10 system like meters is easier for our brains to figure out if we're on the ground. And lastly, it's difficult in lat long if I give you my coordinates in any geo format of lat long, and you give me another set of coordinates where you want me to go to find the missing or injured person, there's no way in my small brain or with a pencil and paper that I can figure out the distance and direction from where I am to where you want me to go. Whereas if we use a grid, it's much easier for us to know that if it's in meters, based upon meters, I know that I have to go so many meters east and so many meters north. And with a simple pencil or a calculator, I can figure out even the distance using right angle, you know, the formula to get distance and direction. There are several grids that are currently in use, and US National Grid, as Randy explained, is simply the civilian format of the military grid reference system that's been used by the military since World War II. So it's not a new system. The only difference is there are some spaces between the numbers or letters so that we can see them easier in our minds. If you look at a map of Minnesota, of the United States, you can see that most of Minnesota and much of western Wisconsin is in grid zone 15T. Eastern Wisconsin is in 16T. And then those grid zones are further broken down into 100 kilometer squares. You know, that's about 62 square miles. And if you look at Minnesota and Lake County where I live, you can see that we're in the 100 kilometer square of XN mostly. And then those 100 kilometer squares are further broken down into 10 kilometer squares. Those are the Minnesota maps that Randy was talking about. And in urban areas, we also make our map books where they're broken down into 1 kilometer square. So you can see every building in a residential street, for example. And those of you who use UTM and are familiar with it know that you can easily convert UTM to USNG since they're both based on meter systems. The first thing that we tell people to do if they get a GPS reading in UTM and just have this long list of numbers is we tell them to ignore the last digit, cross out the last digit on the right, because those are in meters. And if I'm looking for you in the woods, I probably don't have to get within a meter or 3 feet of you to find you. I can probably use an accuracy or a precision of 10 meters, 30 feet to get close enough to find you in the woods. So that's why our standard for emergency location marker for search and rescue is 10 meter accuracy. And again, those 2 left-hand numbers are the ones that are changed from numbers down to the 100 kilometer square name of XN. The reason they use letters instead of numbers is because there are 26 letters and only 9 different digits, 10 different digits. And so you don't need as many digits in order to identify those. It also separates in your mind the fact that if you're all in an XN area, if you're within 62 miles of each other and in the middle of that XN 10 kilometers, 100 kilometer square, then you don't have to say those numbers. You can drop them and your responders can just talk to each other on the radio and say, I'm at 2975-3893. And we know where they are within 10 meters, 30 feet. Randy mentioned that the standard geolocation format for aviation rescue is degrees decimal minutes. So it is important that we all know how to convert back and forth. And again, the FEMA policy states that we are supposed to use, if they're responding to help on a land-based rescue, they're supposed to use US National Grid, but we also help them convert, and they are very good at that themselves as well. I think I can give you a short example. This is just an audio of a helicopter response in Florida, and it's about for an injury, and the injury is at a horse arena. And so the dispatcher, if you can hear this, is trying to describe the roads and where the horse arena is. And then the landing zone coordinator on the ground breaks in and says, I've got National Grid coordinates for you. So let's just listen and see how this sounds and if you can hear it.
That's affirmative. It's going to be the horse arena off of Golden Shores Boulevard, which is approximately 5 miles north of 46, a half mile west of US 1.
First flight, this is Golden Shores landing zone on Air Ops 1. Copy.
He's talking with dispatcher now. He's going to give US National Grid coordinates.
First flight, I have coordinates for you if you're ready to copy.
I'm ready. Go ahead.
It's the US National Grid, November Mike 114.
November Mike 114.
114-790.
790. 114-790.
Read that correct.
Good copy. Thank you.
So you heard him say 114790 within their grid zone or their 100 kilometer square, and that's an accuracy of 100 meters. So it's the size of a football field, and the helicopter can go in there and find it precisely. So that's how and why we decided to use National Grid. Now we have to figure out how to implement that now. So our next step is to figure out how to develop a standardized trail sign that will meet all the federal, state, and local wishes, regulations and wishes for how to make a sign standard across jurisdictions. Because like you, many of our trails, whether they're snowmobile, bike, hike, whatever, they go across county lines. And so we don't want people to be traveling and as they go across a county line on their snowmobile or ATV to have to see and learn to understand a whole new system of signs. So we spent 2 years with the help of Shared Geo, with their guidance, to develop a standardized sign. And you would be surprised how specific the guidelines are, the federal guidelines for uniform traffic control devices. For example, we have to use this color. We have to use this exact same font and the size of font. The sizes of the signs are regulated, and even the placement of the screw holes in the signs. And so we worked pretty hard to make sure that this was a sign that could be used around the entire nation and everyone would be familiar with it once they've seen it. After that, we installed our first 135 signs on snowmobile trails in Lake County in the year 2011. But that didn't end the program, because now we have a few more steps. One is we have to then create new trail maps. Many of these systems had maps ready for their users, but most of those maps did not have a grid collar or the annotation around the grid lines on the edge of the map. So you can see on the Northwood Ski Trail map, for example, we show the kilometers in lines and then also have the kilometer number listed on the top and on the sides. So that if someone does get lost, let's say they're at Bean Lake, they're skiing around Northwood Ski Trails and they get stuck on Bean Lake, right where the B is, they can call dispatch, and even if they have cell service, they can call, and even if they are not able to know their exact location, they can say that I'm at, gotta put my glasses on. They can say that I'm at 28 and 40, and that will give us their location within half a mile, within a kilometer, about half a mile. So it will save us a lot of time looking for them. And the same on the snowmobile trail maps. They can read the grid maps, the grid markers going across the top and going up the side and tell the dispatcher where they are if they are following their map within half a mile. The next step, of course, is we have to train our dispatchers and our responders on what US National Grid is, how to convert back and forth, and how to use it. So we have written protocols and guidelines. For example, when someone calls 911 on a cell phone and they're lost, we have guidelines for how the dispatchers, what they would ask them and how they would respond and how they would help those people find themselves with the use of a map or an app. Finally, when we have all this done, we want to educate the public. We've created brochures so that the public will understand about US National Grid and the why and how we're using those signs on our trails. The brochures are put out at trail heads, trail centers, hotels, resorts, visiting establishments, restaurants, etc. And also we're trying to make sure that we have paper maps out at the trailheads so that they can learn how to use the grid collars. And I think I explained this briefly so that they understand how to read the numbers on the signs. We tell them, as in the lower left photo there, you can see, we tell them to read the numbers that are in the big white box. And only if the dispatcher asks them to do this, then he or she might ask them to read the 15TXN if they're in a near a place where the lines cross. So since then, we've added signs in all kinds of different places in Lake County and around the region at some of the state parks, this parts of the Superior Hiking Trail, the Lake Superior Water Trail, which is the kayak canoe trail on Lake Superior, and all kinds of cross-country ATV, ski, and snowshoe trails and ATV trails. It's also in use, as you know, by many fire departments and other emergency response agencies, the Fire Department of New York, the South Metro Fire Department in the Twin Cities, Dakota County, as Randy mentioned, where he works, and in many other states. I believe it's up in about 14 states now, and there are more states and agencies, local agencies involved and interested. Some of them include national parks, like the Kennesaw Mountain National Park in Georgia, where they have 2.5 million visitors a year. They have the ELM signs, emergency location marker signs up there. In Hawaii Volcanoes National Park, I always wanted to go there and see them so that I could write that off as a work trip, but didn't get that done. At the Emergency Management Institute that FEMA sponsors in Maryland, they train people to use US National Grid, and all of their scenarios for their fake imaginary states, cities, towns are based upon US National Grid maps. One of the biggest projects in the United States right now is Cobb County, Georgia. That's a west suburb of Atlanta, Georgia, and those folks have put up over 840 ELM signs along their bike trails and other trails. And you can see that they come in different formats. They have the long, skinny Carcinite or Rhino flexible signposts along their bike trails. They've also put them up at NASA at Cape Canaveral. There are where they get 1 million visitors a year, and their locations around that multiple large area around Cape Canaveral or Cape Kennedy are all marked with ELM signs. And you might not know this or think that this is maybe a conspiracy theory, but it is also true that NASA has left USNG signs on the moon when we were there. You'll have to go there to check out that sometime.
Hey, BJ, it looks like you've got a question.
Oh, good. Let me look at it and see what it is. I don't see my chat.
Have you found these outreach educational efforts successful in getting people to report their emergencies using the grid?
Yes and no. We have found one of the best ways that we've been able to advertise it is to make special US National Grid blue ELM signs for visitor sites like bars and restaurants. Snowmobile trails where we started, a lot of people are traveling and they're looking for places to snowmobile to and stop and get warm, so they'll stop at a bar or restaurant. So we make a special sign for them and put it up right in the bar or restaurant with their own coordinates, and so that hopefully people will ask them, what's this sign? And the restaurant owners can tell them about it and hand them a brochure and a map, etc. I would say that we are not doing as good a job as we can or should trying to get the public to be familiar with these signs, although it's getting better all the time. Almost everyone that I talk to and ask about that, ask them about these ELM signs. If they've seen the blue signs on the trail, they almost all say, yes, I've seen those on the trail. And some people say, I'm happy to see them, I understand them. And a lot of people say, yeah, I see them, I don't really know what they are. So the best thing we're doing to try to alleviate that problem is to put up signs on the trailhead, signs themselves at a kiosk, excuse me, to explain to people who are going out on the trail about what those signs mean and how they work. So the answer to your question is, I would say half the people are familiar with it that I talk to now. Thanks for that question. So places you can find out more about the US National Grid. Let me see, just go back here, yeah. All right, usngcenter.org. If you go to this website, Randy mentioned this already, you will find all kinds of information, not only about the ELM system, the emergency location marker sign system, but also about a mobile app and how you can print your own signs, either off the website, or you can physically go out in the woods if your snowmobile groomer is heading out in the woods and finds a place where they want to put a sign, they can print their own sign by taking a USNG location. And if they have a little portable printer with them, they can print out a sign right there and stick it up on the post. It's temporary, of course, but it's good to know. One of the big problems or challenges or questions that we got from the trail people is, okay, I'm driving my snowmobile, I crash into something and hurt myself. What are the chances I'm going to crash into an ELM marker signpost? Pretty slim. So we need to know where we are at all times in all places on the trail. So ShareGeo helped us develop an app that you can put on your phone, download it on your phone before you leave your home or at the trailhead if you have cell service. And then it will, as you know, it will continue to follow you as you on your map as you travel with an Avenza map. Or even if you don't have an Avenza map, if you have your phone, it will tell you the coordinates on your phone as you travel. The question we get is, will it work when there's no cell service? And as GIS professionals, you know that yes, it will, because we get our coordinates from satellites and not from cell towers. You can also go to the usngstore.com and you can purchase these signs. They cost about $30 for a single one with discounts for multiples. And there are different kinds of signs you can purchase. For example, the standard is on if you're going to put it on a building, you have a 12 by 12 inch sign. On a motorized trail, you have a 9 by 12 inch sign. And on a non-motorized trail, you have a 6 by 9 inch sign. You can also purchase those smaller 3 inch wide and tall decals to put on the flexible signposts if you want, or on signs, smaller signs that you've created. For example, that very small one that's 3 by 5 inches, you can put on a sign that is already there and just stick it on as a small decal in the corner. Campsites, for example. So the goal of all this is to take the search out of search and rescue. And so I mentioned the app. When we put this sign that you can see on the left, we put it at the trailheads, and then we encourage people to download this app on their phone again so that it will change numbers and move as they move. So even if they get injured in a place without cell service, if they can record that number where they are, then they can go send someone out until they get cell service and tell dispatch that number. And again, we'll know where they are, where the injured person is within 30 feet. Randy mentioned a program called GISSurfer. And for those of us, our dispatch CAD systems don't always have USNG available as a default format. So we encourage our dispatchers as well as our responders in the woods to use GISSurfer if they have internet connection. It's a very simple program developed by Joseph Elfeld. And with these two buttons, menu buttons and base map buttons, you can customize this map to the way you want it to look for your jurisdiction, so that when our dispatchers call up GISSurfer, this is what their map looks like. We've zoomed in a little bit. We already have the coordinate grid systems on there, and we have a basic base map. So this is how it comes up. So now if someone calls 911 and says we are injured or lost, if you click on the menu, then you can input the coordinates that they give you. It's a very simple system. Even I can do this. And you click search and mark, and it zooms in right on the way on the map to where they are within 30 feet. You can change the background then so that you can see where they are, what building they're in. You can see that this person is standing outside a large building in the town, and you can zoom in and you can see that the National Grid coordinates zoom in with you. So you have the numbers, and you can see that this person is at 297 and 388. So you can tell your responders in the woods or in the town where this person is. Another thing you can do, which I really like, is you can then go back up to the menu and simply click on, give me a link to this map. So you can copy this link and then you email it to all of your responders in the woods or whoever is coordinating the search. And this same map shows up on their phone. It also shows where they are. And so then they can, with an Avenza map, they can then go to this coordinate. So it saves a lot of time. One of the challenges with that is as the person asked, if people don't give us their coordinates in National Grid, we can do two things. One is we can tell them right while we're talking to them to download USNG App on their phone, and it will give them the coordinates. Or if they can't do that, let's say they don't have a smartphone, they have a GPS and they have a flip phone, but their GPS is in these other formats, degrees, minutes, seconds, for example. So you can take any of these formats, which all show the same place. You can take any of those from a caller and again, put it back in the search map for GISSurfer. And then as it says in the lower left, you simply right click on that spot and it converts whatever coordinates they gave you, it converts them to all the other coordinates that you might need. For example, if you're calling in a helicopter and they're using decimal minutes, you can convert it from decimal degrees that you might have gotten from the missing or lost person and could immediately convert it to decimal minutes for the aviation response. So we're talking about, for Lake County, we're usually talking about thousands of miles of woods or water. But it's important to realize that USNG is also extremely helpful in urban areas, in large parks, for example, or even in parking lots. Let's say you're in this parking lot and you have, your friend is having a heart attack and you want to ask an ambulance to come respond, but how do you tell them where you are in that parking lot? If you can just give them USNG coordinates, they know where you are within 10 meters and they can find the car that you're in. So that's helpful too. What about transportation corridors? If railways go through cities or the woods, we had, one year we had a railroad engineer who had a heart attack while he was driving his train. And so the other engineer was trying to tell us where they were. And finally we found a road crossing that they came to, but they didn't have any way to tell us where they were on the train. But think of all the railroad and other rail line facilities in cities, that would be helpful as well. Large warehouses, you can use US National Grid even for indoor coordinates in large building complexes. And finally, especially in Minnesota and Wisconsin, think of the lakes that we have in urban areas. This is Lake Minnetonka. And if you have a boat crash or a medical emergency on your boat in Lake Minnetonka, how do you describe which of these islands you're on? So US National Grid would be helpful there as well. And I know there's been more than one response by the Sheriff's Office in Hennepin County and that were on the Mississippi River, for example, where the US National Grid coordinates led them directly to someone on the river for rescue. I also know that in the city of St. Paul in Lilydale Regional Park, you might remember that in 2014, there was a school trip that went to Lilydale Regional Park in St. Paul, and there was a landslide, and 2 of the students died in that landslide. But there was a delay in how to find those students by the description in the park. And since then, the city of St. Paul, after investing over $1 million in claims and investigations and litigation and engineering studies, has invested $700 and some on ELM signs for that park. So there is a great return on investment also for urban area responses. So let's tell a couple stories. Now that we've got our signs in and we've educated the public and created maps and trained our dispatchers and responders, in January of 2013, this was our first time that USNG really helped us, is that Lydia Mink came up to Lake County from the cities and she went skiing on our Northwood ski trails. Beautiful trails, it was a lovely day, but she got a little turned around, a little mixed up and a little bit lost, and it got dark. She was cold, she didn't have a light, she was alone. There were wolf tracks on the trail, which there usually are in that area. So she was scared and she finally came upon a sign that said, "For help, call 911. It was a blue ELM sign. And so she did. The dispatcher asked her to give him the numbers that were on that sign. And she read in the numbers and he could immediately then tell exactly where she was. He called out our rescue squad and we have paper maps. As Randy mentioned, it's always nice to have paper maps, and we have the signs listed on the paper maps. So she was at 2766-3955. And so we could go out and rescue her within literally about 10 minutes. And the alternative to that, without those geolocation information, would be to take snowmobiles out and cover all of those ski trails until we found her. And so it saved Lydia a lot of anxiety and discomfort. It saved our responders a lot of time, and it even saved the trails from getting snowmobiled over all the ski trails. She also made the paper in our local paper and the St. Paul, Minneapolis St. Paul Pioneer Star Trib. So once you put in those coordinates, then you can zero in on them pretty much and find Lydia. You simply put the coordinates, if you want, into Google Earth, and it zooms in and tells us exactly where she was. And you can see that she ended up being very close to a road, and that's how we could take a snowmobile in there and find her very quickly. So a couple more stories. Unfortunately, the first couple stories are about confusion when we did not use National Grid, and it would have been helpful if we did. And so in 2014, we had a Boy Scout party from Ohio visiting the Boundary Waters canoe area. And there was such a windstorm that their canoes flipped, and it was cold. It was June, so it's still pretty cold. The water's cold, and many Boy Scouts were in the water, and we were searching for them by aircraft. So the Ontario Provincial Police helped us out, and they saw a floating canoe, and so they gave us coordinates. They gave them in UTM, and other people were trying to give coordinates also. They gave them in degrees, minutes, seconds, and degrees, decimal degrees. None of those are the two formats that we're supposed to be using for land-based search and rescue or aviation search and rescue. The other confusing part about, if you look at the degrees, decimal degrees they were given out to 7 decimals, which of course is a precision of about ½ an inch. And we don't really need ½ an inch precision when we're looking for someone floating in a lake. So again, the extra numbers of latitude and longitude just add to the confusion and possibility to get the wrong digits. So we had an after action review of this event. And of course, one of the big suggestions was to use our geolocation standard units of National Grid or decimal minutes. A year later, we had another accident or incident in a very similar place in the Boundary Waters. And this was a group of canoers who went over a rapids or little waterfall that they probably should not have. And one of the canoes flipped and pinned against a rock and pinned one of the students against a rock by his leg. And he was in the water there for about 5 hours waiting for rescue, time to get word out till they could reach cell service and get help, and then time to get the responders there. Learning that we couldn't get the student off the rock for a while, and that the student was hypothermic and had a leg injury, we requested a helicopter to come in and help us. We have the wonderful asset of a Minnesota Aviation Rescue Team, which is the Minnesota State Patrol helicopter with some St. Paul firefighter responders. And so the coordinates were given in lat long, but they were given just with digits, not with any units. And so they were given in the standard decimal minutes, but the Minnesota Aviation Rescue Team assumed they were degrees, minutes, seconds. So as you can see from the map on the left, the red dot there, the pink dot is where our victim is, and the helicopter flew over us and was flying around over a mile north in Canada looking for us. And they got on the radio and they said, "We don't see you down there." Took us a while to figure out that there was confusion about the lat long coordinate format, and they were using the wrong one. It's fortunate that they didn't assume it was decimal degrees, because if they did, instead of being 1 mile away, they would have been 12 miles away, also in Canada, and obviously far from helping us. One of the examples of where USNG has worked out well, this is in Cook County, our neighbor in the Arrowhead, and they had 4 people on the Superior Hiking Trail who were lost, and again, were out after dark, and were cold and hungry and tired and wet. And they called 911, and the 911 dispatcher texted them back and forth and told them how to download this app and get their numbers and tell us those numbers. Then they paged out the rescue squad, but the nearest place to meet the Superior Hiking Trail with a motorized vehicle like an ATV was far away. These are kilometers, you can see. And so he talked the people into how to guide them through walking down the Superior Hiking Trail until they could meet the ATVs at that location. And it therefore saved them time to wait for the rescuers, to prevent the rescuers from having to hike a couple of kilometers in to get them. So once again, we knew where they were the whole time. It saved time and discomfort for all concerned. So US National Grid has been so successful for us in Lake County that we've actually written it into our Northeastern Minnesota Interagency Search and Rescue Plan. This is a plan that we work with of all of our response partners, the 3 county sheriff's offices, the national forest, the national parks, the tribal partners, the Minnesota Department of Natural Resources. We've all agreed in there that we're going to use US National Grid as our standard for land-based search and rescue.
Hey, BJ.
So to close, yep, yes, ma'am.
I've got another couple questions.
Cool.
Do you think the system is in meters? Do you think the system is in meters impedes buy-in to the system?
I can answer that by saying probably, because a lot of people aren't used to using meters yet, but I can also say that there is no better option. And that's why we work to train the people to understand that it's a grid in meters. The only other option would be put grid in miles or feet or something, because we want to use a grid so that it's flat squares on a map. But the fact that English units like miles and feet are even more confusing. We know that it's pretty easy to teach people how to use meters, a base 10 system. We probably all learned it in 3rd grade, how to use a grid and a graph to count, 1, 2, 3 on the x-axis and 1, 2, 3, 4, 5 on the y-axis. So we can understand a grid if we have squares, and the advantage of having squares in meters, and of course it is a standard around the world compared to our English system, but also it's pretty easy to teach anyone to use a base 10 system like meters. And almost everyone has heard of meters at least, and especially people who are cross-country skiing, work in kilometers anyway. That has been a great help to us to start with some ski trails where people go, oh yeah, kilometers. I know the ski races are all in kilometers. The Birkebeiner's in kilometers, I think. I'm not a ski racer. But so I think the answer is yes and no. We just have to do a little more training, and it's the best system we can do it with.
BJ? BJ?
Randy, go ahead.
Yeah, I could just weigh in because, this does come up. I mean, I just tell people, don't worry about it. It's meters, don't be afraid of it. I mean, it's basically one giant step. It's about a yard. It works well for these emergency response situations because we don't have to work, the numbers don't need to be so big, and so most people have heard of it, and I just get past it as quickly as possible. Say, well, just because it's in meters, really, you don't need to worry about that. Just use the numbers. You teach them the basic concepts of how to use the settings on their GPS, how to read on the map, and the units really don't matter. I mean,
that's true.
You just move past it and tell people, no, don't worry about it. It's not a problem.
Yeah, for example, Lydia, our lost skier, she didn't care what the units were. Nowhere on there does it say what the units are. She just gives them the number. And the dispatchers and responders, it helps us when we train those people to know that it's in meters. But you're right, the brochure that we printed explains that it's in meters, but the signs, for example, or we don't ever say that they're meters when we teach people about the signs. Thanks, that's a good point. Was there another question, Claire?
Yeah, do you see the E911 system transmitting US National Grid instead of lat long in the future?
We hope so, and I think there are some CAD systems, computer-aided dispatch systems, that do that already. The one that we have in Lake County does not do that yet, and I know that Shared Geo and other GIS professionals are working to try to support that, and sheriff's offices, once they're trained, are asking for it. So I think that it will get better. I also think that me being not a techie GIS person or dispatcher, someone else might be able to answer that better. I know there are answers that there are new CAD systems working to incorporate them. I don't know what they are. Other questions?
That's it in the chat for now.
Cool. Well, I think this is my last slide. So I just want to thank everyone for coming. And I want to make, just summarize by saying that the steps we took, we had to make signs, we had to make maps, we had to train our dispatchers and responders, and now we're working on the public. I have some other personal goals, trying to make USNG the default setting when GPSs come out, and the default setting on maps, like the canoe and hiking maps in other places. I know that US Geological Survey maps, Topo maps, etc., have UTM coordinates on the side, but this is required by FEMA for federal agencies. So it's kind of a top-down requirement, but I want it to come from the bottom up, from the users, from the public, from the canoers and hikers and people who buy GPSs. They might not even need to know, as Randy said, they might not need to know that this is in meters or even what the system is, But if the GPSs that people buy have a default of National Grid instead of some form of lat long, that would go a long way to helping people learn to use it. USNG has made a difference in many, many rescues in our area since that time, whether it's helicopter rescues, rescues of missing persons, snowmobile accidents, all kinds of things. So we are promoting it. And the last thing I want to say is that I did this, I've done this presentation a few times for other rescue squads, et cetera. And I've had then the rescue squad captains or the sheriffs come and ask me and say, will you come and train our responders on how to do this? And I'm not promoting my own training. I'm just saying that once they know about it, they see what a difference it makes and how valuable it could be, and they ask to become a part of it. So I hope it continues. Thank you. So Claire, I wonder if we should, or Randy maybe is going to be next up. Do you want to take another break? And I'll certainly stay around to answer questions or things that come up.
I think we can do a 5-minute break.
All right. Thanks, everybody.
All right. Everybody back? I'm sharing my screen. If we can see my screen this time. You see my screen, Claire?
We can see your screen. Yep.
Okay, great.
It's the maps.
Yep.
Yep. Okay.
Okay. I've seen some comments. Thanks for that. If you would, make sure that you're sending the comments to everyone so that we can all see the questions when they come up. And if I miss one, somebody please feel free to interrupt so we can address it. And there was one question that I want to make sure I answer at an appropriate place here. Is a grid built to 1 meter level across the state of Minnesota? If so, how did you go about building that? The answer is no, and it isn't necessary. So I want to get to really the root of the question, Art. So at an appropriate point here, I'll ask you to explain why you think you need a 1 meter grid, because you really don't. But I think we'll find a good spot here along the way to talk about that. So I'm going to start with some slides. The focus of this segment is making maps, making U.S. National Grid maps. And I'll go through some examples, some slides from ArcMap. That's what I used originally, but I've now migrated to ArcGIS Pro. I would like to see, if I can, everybody use their, let me see if I can get everybody. There, I think I can see everybody. If everybody would use the, let's see, you've got the button to annotate, or not annotate, but what is it, the respond thing? I don't see it in my control.
Reactions.
Reactions. Everybody use a reaction if you consider yourself an ArcMap user. All right. Okay. Great. All right. Give it a minute. Let those go away. And now user reactions if you consider yourself an ArcGIS Pro user. Ooh. Come on. 3. All right. Well, for the first examples will be all ArcMap, and then what I'm going to do is switch over to a live ArcGIS Pro session and give some detailed examples there. And along the way, we can talk about the 1 meter grid question, and then Art, make sure that I answer your question along the way. All right. All right. So this is all about maps, and you've seen this slide already. It's about pre-building these maps, printing a strategic number of these maps and distributing them strategically so that people have them available and know how to use them as well. Where am I? There we go. And then creating the map books, and I talked about this as well. Creating maps that are consistent across jurisdiction. We end up with a map library. These are all created as PDF files. And so this is all about creating those PDF files. Once it's really all about, if you've worked with, well, let me see a show of hands. How many have used data-driven pages in ArcMap? Give me a reaction. 3. Well, this is what it's a great feature in ArcMap, and it's carried forward in ArcGIS Pro with the map series. It's creating a whole series of maps based on a single layout, and what you do is drive the creation of all of those maps based on a polygon data set. So you can identify a polygon data set or selected polygons in that data set, and that becomes the basis for creating all of the maps. What that means is then each of the maps, I mean, it'll automatically create a map for each of the selected polygons, and the attributes that are associated with those polygons are then available as dynamic values for each map. So it means it's really all about pre-building those polygon data sets as the foundation for creating the map series. So that's what this is all about. But at a fundamental level, all you need to do is put a UTM grid on the maps you're already making. I mean, if I've been making maps for a long time. Started working at Dakota County, it was all about the county coordinate system because I was working for the county surveyor, and county coordinate system was the best way, most accurate way for capturing coordinates for parcel corners and parcel definitions. And that's still true. That is a local projection. It gives us the best representation of actual ground locations and ground measurements. So we're not replacing that, you know. All we're doing is taking data that's stored in whatever coordinate system. It doesn't matter, county coordinates, state plane coordinates, UTM or whatever, geographic, presenting it in a universal transverse Mercator projection with UTM coordinates. That's the difference. So it doesn't matter how you're storing your data. You still want to make maps in county coordinates for your county surveyor. That's no problem. But you know, I challenge you to, if you're an advocate of county coordinates or a local coordinate system, how many other people know about that? And it certainly is not universal across jurisdiction. It certainly doesn't scale up for the entire country. So it's important to consider that. So you're already making maps, put a UTM grid on it. You never know which maps are going to get pulled out of a drawer in an emergency situation and used. And so this is the common denominator for how we make maps useful for emergency response. Of course, they have to have the training. You can do just-in-time training on how to use the U.S. National Grid in a pinch if you haven't been able to do that ahead of time. And you may have to do it with search and rescue operations. And certainly when you get into a major weather event or something like that, there are a lot of volunteers that are going to come out, and you can do just-in-time training. Give them an 8.5 by 11 map. Give them tell them how to set the MGRS setting on their phone so they can see where they are, and tell them to go to a certain grid location. It's not hard to do. They don't need to know all the details. So I was actually just talking with somebody in a suburban or rural county just outside of Atlanta, and he wants to start making U.S. National Grid maps and so on. He's already making maps. He's not doing the map series based on the U.S. National Grid, but he already has a map book at a certain scale and so on. And I said, put a grid on it. That's the very first thing you can do, is make sure that the grids that you are producing are U.S. National Grid compliant. So that's the fundamental message that I want to leave with you. You're already making maps, put grids on them. We need to have some kind of a spatial reference. I mean, this is something I learned a long time ago when we were drawing maps by hand, is you always have a spatial reference on your maps. How else are you going to measure on it? How else are you going to use them? And certainly now with virtually ubiquitous GPS, everybody thinks they know about GPS because they've got it on their phones. How do you relate that to a map? Put a grid on a map. And if you're going to put a grid on a map, put a UTM grid on it so that it's interoperable with the U.S. National Grid. All right, that's the most important thing. But then it's really about creating standardized maps. So you want to have maps that are consistent across jurisdiction, as we did in Minnesota, create maps that are consistent across the entire state. Obviously, the USGS has created the USGS US topos. Those are consistent across the entire country. Those are based on 7.5 minute by 7.5 minute quadrangles, which works well when you're starting from a national scale and working your way down to a 1 to 24,000 scale. The interesting thing at a local level is that these other maps that are based on the even increments of UTM grids or the US national grid is that it works well from down to a very large scale map at a local level. And so that's where we came up with these 1K and 10K maps. The 10K maps are 1 to 24,000 scale as well, same as the US topos. So what I tell people is when you're starting from a national level and working your way down, the US topos work great. When you're working at a localized level, the maps that are based on the US national grid work great because it's very easy to figure out which map you need to be on. Again, I challenge you with the US topos. They're all named with historic names. Trying to figure out which US topo you need for the location that you happen to be occupying, it can be challenging. And so that's where this 1K, 10K maps work very well because they're named using the coordinates of the lower left corner of the map. Works very well. And the name of the map also, by definition, describes the geographic extents of the map. So if it's a 10K map, it'll be something like VK85. And so we can see just by its name that it defines a 10K square, and the lower left corner at a 10,000 meter increment is the X and Y of the two characters. Then when we get to 1K map, that's a 1,000 meter by 1,000 meter, even increments. It's two characters, X and Y, which is the lower left corner. We know because it's only 4 digits that it defines a 1,000 meter square, and so on. And so that gives us the ability to name these the files, the PDF files that are associated with these maps. You have to always come up with a unique naming system. And so what are you going to use? Well, if we're actually naming the files based on the coordinates of the lower left corner, it's guaranteed unique, first of all. We can append a descriptive name. So you might have something like VK85 underbar topo or VK85 underbar aerial or something like that. So you can add that additional name for naming these map series. But that means if somebody's searching through these PDF libraries, just using the name itself, they can figure out which maps they need very easily. But then also developing some standards for the USNG data field name. So again, it's all about these polygon data sets and the attributes that are associated with those polygons, because that's what drives the map series. So there's some time involved in getting this all set up properly, but once it's set up, it's done, and you're simply able to rerun your map series, and everything works. So what you do is set the attribution on the polygons so that becomes the dynamic text when the map series runs for populating some of the fields that we'll see here. And standardizing the maps, again, based on the 1K squares and the 10K squares. Everybody understands we're talking about 1,000 meter by 1,000 meter and 10,000 meter by 10,000 meter on even increments of the UTM coordinate system. But it works very well when you're working between these. If you think about an 8.5 by 11 map at 1 to 6,000, that's 1 equals 500 feet. Once you have your layout set up, you change your scale from 1 to 6,000 to 1 to 60,000, and now you use the 10,000 meter squares, or 1 to 600,000, and now you're using the 100,000 meter squares. And so what that gives you, then smaller scale maps become the index map for the larger scale maps. And you just work your way down. And it's very easy to do. Same thing with 22 by 24 or whatever format you choose. When you're working directly with, when the map extents and scale relate directly to these even increments of the US national grid, it's worked very nicely to scale by a factor of 10 and create an index map for the larger scale maps. Works very well. Here you can see that. So we've got a 1K map, that's 1 to 6,000, 1 inch equals 500 feet. Multiply the scale by 10, add a 0, and now you've got a 10K map with its 8.5 by 11. Multiply that times 10, add a 0, and now you've got a 100K map, and you can label all of the squares, and so you instantly have an index map from one to the next, and it just works very nicely. So you can think about that as well. Any questions about that? Okay. Am I doing? Oh, okay. So here's an example. So here's the 10K map, 22 by 24 inches, 1 to 24,000 scale, 1 inch equals 2,000 feet. Right up in this area is a refinery in Dakota County. Well, you know, that's a very detailed industrial area. And if we want a detailed map, again, at the same size, 22 by 24 inches, I changed the scale from 1 to 24,000 to 1 to 2,400. And now I have a 1 inch equals 200 foot map showing 100, a 100 meter grid over that same area. And so I can very easily use the 1,000 meter polygons to drive a 100 meter data set, and so on. And so the question about the 1 meter data, you really don't need it. And it would be monstrous. It's just totally impractical, and it would just be huge. And you just don't need it, because the only real grid data that you need are the polygons to drive your map series. Everything else is just lines on a map. Or if people are using the U.S. National Grid for asset naming, it works very nicely for that, because you're guaranteed a unique identifier for a light pole, a fire hydrant, things like that. But you don't need the data to actually do that. You can just, there's a tool in ArcGIS that will allow you to calculate a field value using U.S. National Grid or MGRS. So you don't need the data all the way down to 1 meter. You're using the gridding capabilities within the map systems to be able to generate the grids on the maps, or in an application. So does that help with that 1 meter question? Give me a thumbs up or unmute. And we'll see more examples. I'll touch on that along the way. Art, you okay with that? All right, great. All right, so just point out resources, because I want you to be able to go away from this and go dig. Take a look at some of these examples. If you do a Google search on USNG Minnesota maps, I think probably you'll get to this page. And if you scroll down, we actually have instructions in a zip file for getting everything that you need to be able to recreate those maps in ArcMap. And it also exists on usngcenter.org. Go down under library mapping support. Here you can download instructions for creating 1K maps and an MXD with that layout. Don't start from scratch, please. One of the other benefits of this, if we all do things the same way, we get to leverage each other's efforts and make improvements together and learn from each other. So there's no reason for anybody to start from scratch with creating these kinds of things. And if you got a better idea, I'd be glad to hear about it. I know some people are creating some maps for 11 by 17 and things like that. The scale can be challenging, and I've found the 8.5 by 11 and 22 by 24 formats to work pretty well. They're pretty economical to print. 8.5 by 11, obviously anybody can print those. But there are certainly other options. But let's try to create some standardization on this stuff and really take the stuff that's already out there and start with that at least. So you can download the instructions. It takes you through actually setting up the map book. And then you have to download the USNG grid data. And this again gets to that question about the 1 meter data that you really don't need, but you do need polygons for whatever increment of the US National Grid that you want to use for your map series, just as you would for whatever kind of map series you want to create. If you're creating half section maps or section maps or something like that based on the public land survey, well, you got to have polygons for the half sections and set up all the attributes accordingly. Same thing for creating these US National Grid maps. Now, all of that data exists down to the 1,000 meter squares nationally. So you can go and get all of that. And there is attribution on there already for the US National Grid. I've really found that expanding on that works nicely. There are some improvements that can be made in the data that is out there. It's actually organized into UTM zones by state. And so for the state of Minnesota, we actually have 3 different UTM zones. State of Wisconsin has 2 UTM zones. So you have to download the 2 pieces. What I've found is that it works real nicely just to mash that stuff together in WGS 84, keep all the attribution there. And then you're working with 1 polygon data set. So you'll do some things as you get more familiar with it and you start playing around with the data. You'll find some ways to be able to streamline that and come up with really a good foundation for creating your map series, whether it's for the entire state or for a county. Just play around with that and you'll find some efficiencies, but it's all about building those data sets. You can actually then download the MXD. This is for the 1K maps, 1 to 8.5 by 11, 1 goes 500 feet. And then you follow the instructions for making the maps and map books. And I believe these instructions are really pretty straightforward. You can just follow the instructions. You don't have to do anything to the data. It will just work. But then what you'll find is that if your county is split by that grid zone boundary, there's some other stuff that you're going to have to do, as I will show you here. And then step through creating the USNG Map Book. So it takes you through the preparation and setting up the data-driven pages in ArcMap. And I think this is really pretty straightforward. Just follow the instructions. And if nothing else, it's a good way to learn if you haven't played with data-driven pages. Just work your way through this. Use the standard Esri base maps and make some maps. It'll help you understand a little more about how it all works, and then you can build on top of that. So it's all about building the data. So I've got the 1K polygons for the entire county, but what I can do is then use something like a municipal boundary. This is the Apple Valley showing on the screen. I can select all of the polygons associated with Apple Valley. And then I can make the index map. I can use these selected polygons for data-driven pages and just recreate all the maps for Apple Valley. So I can do it countywide, or I can just do it for a selected area. Obviously, you could get more sophisticated, if you have a way of tracking updates to your database. You would be able to figure out which are the polygons that are affected by the changes in your database and only create the maps that have actually changed since the last time you updated your database. I mean, it's pretty slick. Lots of different ways that you can leverage this. Okay, so then setting up data-driven pages, just some screen grabs of that. You specify the layer. And then you can specify the sort field, and then there are options on the name of the page, and so you can actually use the attributes. So if we have an attribute on the polygon that is the U.S. National Grid designation, like 15T VK8475 would be a 1,000 meter square. That's an attribute value that's unique on each of the polygons, and we use that for the file name. And so as it creates all of these maps, they all get named uniquely, given the correct name, and it works pretty slick. We do want to center and maintain the current scale. We don't want any best fits and things like that. The 8.5 by 11 format at 1 to 6,000 scale works really nicely for a 1K square with a little bit of overlap around the outside. So it still gives you, the overlap between the pages and things like that, which is nice to have. We've actually we've changed our format a little bit to make the map display the map frame square and allow some extra room down at the bottom so that we're all set up for doing situational overlays. So we got extra space, white space down in the legend area for, you know, tornado damage or whatever. So think about that as well. And then you want to be able to set up a location indicator. And so that's going to be another map frame. You can do this very easily with the same 1K polygons. You have another field in there that is just the numeric portion. Again, at a localized level, we don't need to keep beating to death the 15 TVK. There are only, in Dakota County, we have two 100,000 meter squares, VK and WK. And in fact, you know, Dakota County is about a medium-sized county, I think. The numeric portion of the US National Grid does not duplicate from one end of the county to the other. Now, because there's that 100,000 meter boundary right in the middle of the county, the numbers actually increase up to 999 at that point and then start over at 0. So that's can be a little bit weird, but so we do put the VK and WK on the maps so that people don't get confused about that. And they just know VK's on the west side and WK's on the east side. And it's not hard to figure out, but everything gets numbered sequentially. Even if you don't have all the pages, it's still going to be sequential. So all the pages, when you can order them very easily for creating the map book. You know, don't have to be numbered 1, 2, 3, 4, 5 in numerical order without any gaps. It's okay if there are gaps in there because it's still sequential. So you have the index map, it shows you all the page numbers, actually numbering from the lower left corner up and so on. But it's a very logical system. It's very easy to be able to see what are the adjacent numbers and things like that. And so some of the things on the bottom of the map, I'm not sure how well it's showing up on your screen, but we have the grid zone designation box, which has 100,000 meter square. We have the grid zone itself, which also shows up in this text. And you'll see this in greater detail. It's pretty small here right now. But things like the map number and then the index to the adjoining pages is all coming off of those polygons. So you don't have to go to every map and put this in. It all gets generated automatically using data-driven pages in this case. These are attributes of the page for each page as it's created, which is pretty slick. And then the pages themselves. So you give it a file name, which is actually the root of the file name, and then it appends the whatever you're using, whatever field value you're using for the name, and we use the USNG. And you should use the full USNG specification. So here we want to use the 15 TVK along with the numbers. That way, if for some reason we merge it in a much larger library, the names will still be unique and they will still describe the actual location of that map. So use the full designation. Don't cheat on that at that time. Some of the other things you need to think about, the projection should be UTM NAD83. You need to put a grid, and it should be a UTM grid of an appropriate appropriate increment. The grid zone designation box, we'll go look at these in detail. The grid labels for small scale and large scale, the graticule, and the magnetic declination diagram. So if we look at a map, let me see where I'm at here. Oh, okay. In ArcMap, you can just go, oops, thought I was live there. You can just go into add a grid, and you can specify US National Grid. It's right in there. You don't have to do anything. Now, problem is, the way this is set up is it really only works down to a 1 to 24,000 scale. You know, it's really designed for the way the USGS creates the maps at a relatively small scale. At the local level, we need to do some additional work to be able to make the gridding work properly. So it's important to know what it is that you're trying to achieve here. You know, you can't just push the buttons and expect that it's going to do it properly. You need to know what to do. And we do add a graticule as well. You know, we did show in the National Search and Rescue Committee standards, we need to be able to support both the U.S. National Grid and degrees, minutes, seconds. Degrees, minutes, decimal minutes. And so it's important to have both of those on the maps. And so here you can see that. I should have showed a different example because we've actually changed this one. But here you can see we've got this. We have the full coordinates in the corners, and you should always have on the at least one instance on the map where you're showing the full coordinates in X and Y. So you want to make sure that typically it's in a corner. And then we're labeling the grids, and this is really the first iteration that we came up with. So we can see that the name of this page is actually 7250. And by just using the digits on the grids, we can get to a grid reference for a 100 meter square. So 721501 would be this square up here. Very easy to do. We had some debates really with people are doing this across the country, and what we've actually come up with as an extension of the standard is to use 3 digits for the grids themselves, and that I think fits the standard better. But here you can see standard text that needs to appear on your map. 100 meter grid, it defines the increment of the grid, U.S. National Grid, North American Datum 1983, that's part of the standard. Grid zone designation 15T, 100,000 meter square identification VK. The VK and the 15T are all being driven from those polygon attribute values. And then in the same way, this grid zone designation box, this is a standard too. So then we do in ArcMap, we can really just do the U.S. National Grid, but then we need to add these 100 meter lines when we're doing a 1 to 6,000 scale map. If you're just doing 1 to 24,000 scale, U.S. National Grid works fine. Once we get to a larger scale, we need to start adding something else like 100 meter grids. And then we need to set the interval. There's some weird to set the interval to 100 meters. There's some weird things in ArcMap. I don't know if they fixed this by now, but I had to actually set the origin and do a slight offset to make it work. So again, it's all about knowing what you need to do and then use the tool to accomplish that, as opposed to letting the tool drive it. You need to know what you need to know first. Putting in some corner labels. It's setting the principal digits. And so again, the little numbers and the big numbers, the numbers and the superscripts. And so that's the convention that helps people interpret the UTM coordinates into U.S. National Grid references. The Bible is the FGDC standard. You need to read this. There's a lot of good background information. You can see it's dated 2001. I don't think it's changed since then. But this is where it all starts. This is what describes the elements of a U.S. National Grid compliant map. So you need to look through this, and I'll just point out a few things. It shows you the grid zone designation box. It shows you that text. You need to define the increment of your grid on the map, grid zone designation in 100,000 meter square. Shows you how to label the grids. Again, having at least one complete UTM coordinate on the grids on your map. And then this is another part of the standard. If you are at if your map includes the intersection of 10 kilometer squares, they are labeled in the corners like this, as well as in the marginalia. And that all happens if you just click U.S. National Grid and you're working at 1/24,000 scale. That this just happens, and it'll show up on your larger scale maps as well. You can see how the grid zone designation box changes, and so that gets a little more challenging. And I'll show some more detail about this in the ArcGIS Pro examples. And so here's just all of the examples of the grid zone designation boxes, depending on the different configurations. Now, here's one reason why creating maps based on the U.S. National Grid, even multiples of 10 on the grid lines works well, because you don't encounter this very often. So that works very well. But be aware, and you can drive a lot of this from the automated data-driven pages too, and I'll show that. Again, graticules. So these are your geographic references. And so we do need to put degrees, minutes, decimal minutes. The typical technique is to put ticks so they can be differentiated from the grids, so you don't have grid lines all over the place. We typically put the graticules in as across a plus sign at the intersections, and that can all be done through the gridding as well. And do that at some kind of decimal degree increments. So you need to play around with that. You need to make sure they're labeled in degrees, minutes, decimal minutes, and you just got to find a convenient increment for the scale that you're using. 0.1, 0.25, whatever. You might play around with it. 0.2, play around with that, but you want it to be a nice even increment. Don't let it just, if you don't pay attention, you'll end up with some weird thing like 0.2763 or something, and that's just confusing. Find a nice even increment. 0.125 is a certain even number of seconds and things like that. So play around with that. Magnetic declination diagram. This is true north, magnetic north, and grid north. This used to be a big problem. Esri had a tool for creating this automatically, but it was only included if you paid for the military extension, which was really unfortunate. However, Shared Geo, once again, thank you, came up with this little utility, which is very useful. It'll automatically create the declination diagram based on certain arguments, and this is a web service, so it's actually just been updated. Actually, I'll show that in a second, but it has the arguments that you see there. In case you didn't realize, magnetic north changes over time. It's actually moving, so you do need to specify a year. Specify the latitude, longitude of the center of your map, the UTM zone, and then a size for the image, and it simply returns this as a PNG. Well, that means you can drive this from your data-driven pages as well. You include in your polygon the latitude, longitude of the center of the map, which you can calculate very easily, just using the standard ArcMap tools, calculate geometry, and then put in the other attributes. So you can actually create this full URL as an attribute on the polygon that's being used to create your map. And as it creates each of those maps, it will go out, hit this service, return the PNG, the correct magnetic declination diagram for that map, and plug it into the map. Very slick. You can actually go to mdd.sharedgeo.org. And they just recently added actually a form, so you can just go play with it. I mean, you could go type in all the arguments on the URL address if you wanted to, but you can also just go to mdd.sharedgeo.org and use the little form that's down at the bottom, and it'll generate the PNG. So pretty slick. So if you just need to create one for a single map, there's a nice way to do it too. So then you get to, I'm not sure why I put this slide in. Once again, you've seen this. We're creating the map books. I think we're actually going to look at them. Okay, here's the new example. So this is the next generation of these 1 to 6,000 scale, 8.5 by 11, 1 inch equals 500 foot. So we're including the magnetic declination diagram, which we didn't before because it would have been painful. You can see we've got all the same stuff that we've had that you've seen on the 1 to 24,000 scale maps, but then look at how we're labeling the grids. So now the principal digits are those that apply at this scale. So again, the full coordinates, and then using the 3 digits as the principal digits, which gives us the actual grid reference. So 833511 is the grid reference for this 100 meter square. So I think that it makes it much cleaner. It really follows the convention much better, and encourage you to do things that way. So then we've got a special case, grid zone boundaries. And this was actually, some people thought that we can't do US National Grid because we have grid zone boundaries. Well, it's just a special, cartographic challenge. It's not a deal breaker. And I've dealt with this in a specialized way. Because what you actually have when you download the 1K polygons, for example, you actually get partial polygons at the grid zone boundary, because it's like a zipper. You'll see it here in a second. And so to make all of them, so if we use those little polygons, they would be centered on the map, which might be good, but I think it's a little confusing because the map looks different than any other map. So instead, what we do is just artificially extend that particular polygon to make it a square, and using all the attribution to create a map that covers the area that square would occupy if it were extended. We cannot. Every location has one and only one US National Grid reference. You can't just arbitrarily extend the coordinate system out into another zone. Yeah, all the GPS applications will automatically make the switch as you cross that boundary. So we don't want to create confusion by artificially extending that. So what we really need to do is represent both grid systems, the grid system from both zones on the map. And then we have to have some additional fields for the grid zone designation box. And bottom line, ArcMap gridding fails. So those of you that aren't into ArcGIS Pro yet, you really have to deal with this problem. You're going to want to go to ArcGIS Pro, and really everybody should go to ArcGIS Pro. It's only a matter of time. There's no reason. This is a good reason to do it now. It actually handles this problem very well. We had to really go through some contortions to make ArcMap work with the first set of maps we made for Minnesota. Now in ArcGIS Pro, it does it right, and it looks really nice. So here's the grid zone boundary. You can see it in the heavier line running down kind of the right third, and you can see how the grid lines go off at an angle. It's skewed, and so you have these partial polygons that run all the way down. Well, that's correct. That's the way it's supposed to work. And you can measure and get a correct location any place on this map. Now, it takes a little bit extra to train responders and people that are using the map to measure correctly, but it's really not hard because you measure all the way up to that point, and you need to know which grid zone you're in. And when you're measuring to an adjacent point, you have to measure from the other grid, and you're simply subtracting. So you're just measuring in the opposite direction. It's really not a big deal. It's just it'll match the GPS coordinates that you're getting, which is very nice. If we just look at how that looks, if we look at two maps, so what we end up with by creating those artificial polygons, or pseudo polygons as I've called them, what you end up with is all the maps along that grid zone junction in one UTM zone, and then the overlapping maps in the adjacent UTM zone. So they all overlap, and so you're basically working from, if you're working in one UTM zone using the map naming convention, you get to the right map. If you're in the other UTM zone using the map naming convention, you still get to the right map, and then you can see that you have to go over to the next UTM zone. So it's very easy to work with, but you can see how this looks with the grid skewed. If I just align, what I'm doing is I just rotated to align that grid zone boundary, and if we just clip it at that point, that's how it works. And so you can see that the aerial photography underneath still represents the detail the same, and all we're doing is overlaying this grid on top of it for measuring purposes, and it all works. So it is a special case that you have to deal with at the grid zone junctions, but really in ArcGIS Pro, it isn't a problem. Okay. So now I'm going to go to ArcGIS Pro. Let me see. Yep. All right, so give me a second here, because what I'm going to actually do is bring up ArcGIS Pro. I thought I would have, oh, nice. I'm going to stop sharing for a second. Make sure I got my password right. And I'm going to bring up ArcGIS Pro. And what I'm going to do is actually share my window, because it makes, it'll make my ArcGIS Pro a little bit bigger on your screen, I've noticed. So give me a moment. Oh, that's not what I wanted. And so this is for the 10K maps, but the same concepts apply at a different scale. But again, this is available. If you're going to make 10K maps in Wisconsin or anywhere, you should start with this. There's no reason to start from scratch. And let's see.
Randy, we can't see your screen if you're.
Yep, I am just getting set up. Thank you for that.
Okay.
I need to do a share on a window now. Here I am. There we go. Now you can see.
Yes.
Okay.
It's coming in.
Yep. Okay. All right. So I'm opening up an ArcGIS Pro project now. Let's see. I've got a script I'm going to follow here. So this is working live, but I think it's the best way that I could show you what I wanted to show you and react. All right. So now everybody can see that. All right. Okay, so this is the ArcGIS Pro environment, and it's a project file now in Esri terms. So we're kind of going back for those of you that do ArcView. We're back to projects instead of map documents. So the nice thing is, first of all, where a map document was document centric, you had to create multiple MXDs for, different variations of the same map. Now you're working in a project, and so you really have the concept of view of maps and layouts, which works very nicely. So this is the project for creating the 10K maps for the state of Minnesota, 1 to 24,000 scale, 22 by 24 inches. And the same concepts apply at other scales too. But we have 3 maps, and let me see, I've made this really small, so let me see. So we have 3 maps. We have 1 map for each UTM zone. In Wisconsin, you have 2 UTM zones, so you would have 2. And the reason is because we have to set the UTM zone so we get the right projection. And then we have a corresponding layout, map layout for each of those zones. So we've got I've called them 10K 14, 10K 15, 10K 16. And then there's one more for each of those zones to deal with the grid zone boundary. So essentially you have a map for each UTM zone, and you've got 2 layouts for each UTM zone. All right, so what I want to do is show some of the details about so in ArcGIS Pro, it's called a map series. In ArcMap, it was called data-driven pages. So I'm just going to go through a little more in how you create these maps. And in this case, it's a map series in ArcGIS Pro. So here you can see 1K squares for the entire state of Minnesota. The grid zone junctions are apparent, and we'll see that in a little more detail here. I've got this thing called the USNG reference, which shows the UTM, the grid zone, and the 100K squares. And so you can see all of those labeled, just so you can see how this all works. And so each of those smaller squares are, let's kind of follow my script here. I think what I wanted to do is click on one. And so now you can see I've selected one 10K square, 100K square, and the grid zone designation. And we can just look at the attributes. Let's start with the grid zone. So there you can see the whole grid zone. It has one attribute, NGGZD, which is 15T. Obviously for the other ones, it'll be different, 15U, 14T, and so on. If we look at the 100 square, again, we can see NGGZD. And now you see the 100K2 and NG. And I've adopted NG as the convention for naming the attribute for the full USNG designation at this resolution. So you'll see that when we get down to the 10K square as well. So we got the National Grid stuff broken out into pieces, and that's so we can label the grid zone designation box and the other text. And then NG is for the full designation. And you can see how you derive these values from the National Grid, the full National Grid reference. You just pick out the characters. It's a calc operation on the field. And if we look at the 10K square, this is what actually drives the map. And so here you can see more. You see the full NG, 15T, VM53. So that's the full designation for that 10K square, and then breaking out the pieces. So we got the VM is 100K square, 10K2, that identifies a 2 character representation of the 10K square. So I just want the 5.3 in some cases, and so on. And here's 10K4, and so now I know that that's the full VM53, and so on. And then you can see the URL for the magnetic declination diagram, and that has the full, all of the arguments for driving. Well, before that, you can see the lat long. So I calculated the center of the polygon in geographic coordinates. So we have the lat long of the center. And then from there, this is another calc to build that URL. All right. And then I've also added for consistency a FNAME field, so I could use that directly. But anyway, you can see the attribution there. Any questions about that? I mean, you're familiar with Pro, but you can see how you set up the attributes on the polygon to drive all of this. And I am running low on time, so I'm going to move along. Let's see, the attributes. All right, so if we look at a layout now, we can look at some of these pieces here. So I'm just going to zoom in. So here you can see that text. You've already seen this a couple of times. So the 15T and VK gets driven by the attributes. Grid zone designation box, again, the VK and the 15T, those are dynamic. Actually, if I click on here, let me just hover over this for a second. If I hover over this, you can see the text. And if you look down, you can see the text that is static, and then you can see the DINE in the greater than, less than signs. DINE type equals page, property equals NGGZD, and so that's what's pulling that value out and plugging it in for each map, and that's just the convention. And you can go, you know, it's just using these dynamic text tags in your layout. But it just changes with each page. All right, we looked at the grid zone designation box here, data sources. Another dynamic text in here. If you look down at the bottom, base map, again, dynamic text layout name, and the property is service layer credits. That's a piece of dynamic text as well. So it's not related to US National Grid. That's just another piece of dynamic text that you can plug in. It's kind of nice to be able to take the credits out of your map frame, which can be rather annoying, especially on a large scale map or a smaller map, and put it into the marginalia. So that's kind of a nice thing. We've got the standard legends. These are all the overlays. Actually, all of these layers are coming from national repositories, and it really helps drive the need to update those data sets. And so we're working to standardize that in Minnesota as well. Some additional layers that we've added in Minnesota: standard disclaimer, map name. Map name is dynamic text. You can see that again, NG10K4, and location map frame, and so on. Scales. You know, it's important. Your bar scales are important because you never know with a PDF file. Somebody may take my 22 by 24 inch map and print it 8.5 by 11. Well, the scale is no longer 1 inch equals 2,000 feet. So that's why you want to make sure that you reference the intended size of the map and then all the scales. The north arrow is the magnetic declination diagram. There you can see I'm using the value of the field URL 15 and so on. Oh, okay. Then also, if we go into the map frame, grids, and this is what's really nice. I'm going to just feed this along and go right to the. Well, let's see. I'll just show this first. So, if we look at the grid. It's the, you know what, that's not, there it is. The grids, the most important thing with the grids is that it has this checkbox right here, clip to UTM zone boundary. So you add a grid for UTM zone 15, you add a grid for UTM zone 14, and you say clip them at the UTM zone boundary. And it does all the labeling, it does everything as it should. One thing, it gets a little more complicated, is the labeling of the grids. You can see everything is here. There are some defaults, but again, it's getting familiar with the dynamic text. Esri has some pretty good help on this. I encourage you to go there. It's linked, tells you how to do grid labels, and it actually has labels for US National Grid in here somewhere. Here we go. Measured MGRS label examples. So we're gonna have to expand here again. All right. So it looks a bit more, it is more complex for labeling the grids, but very flexible. And again, you just need to get familiar with it all. So with my 3 minutes left here, what I want to do is go to look at what I did is create this map X just for viewing. And this is where I really set up the different map indexes. So we have the 10K squares, and we looked at those. And if I zoom in and look at one of these, here's where you can see it's actually a partial. Let me see, I gotta wait for my, it's actually a partial polygon. It has all the attribution, but so what I did is, let's see, where am I here? Oh, I closed map X. I'll do that. All right, I'm gonna have to. All right, I lost that. Pardon me. I got to recover here real quick. All right, sorry about that. All right, so where did that go? Sorry about this. Perils of, come on. All right, so real quickly, so we've got those 10K squares, but then I've created these pseudo polygons, and here you can see what those look like. And so those are actually full squares along the grid zone boundary, along the grid zone junction. So had to create those 1K squares, and there are different techniques for doing that. And then copy the attributes from the partial polygons and then complete the additional polygons. So what you end up with as an end result here is creating these different, these are definition queries for the different data sets. So if we look at the standard case, these are the polygons used for creating the UTM Zone 15 standard maps. These are the ones for Grid Zone 14, and these are the ones for Grid Zone 16, okay? But then we've got the special cases, 14X, 15X, and then we've got a little bit in 16. And so if we just take a peek at one of those, and we'll look at worst case, which is up here. There are a bunch of additional attributes. And so here you can see we got the same standardized attributes, but then we had to add the grid zone east, grid zone west, 100K east, 100K west, and so on. Grid zone north, grid zone south, and so on. So those are all consistent. These are just definition queries on that, because you could select all the ones where the east and west are the same and the north and south is different, and then that tells you that it's one of the horizontal seams, and then you could look for the other ones where east and west are different, north and south are the same, and so on. So it all works. It's all really slick. It looks complicated right now, but it really is slick once you get familiar with it, and then being able to drive that. And if we just look real quick, and we're running out of time, but I'm just going to go to the layout for one of these grid zones and one of the grid zone junctions. And if I zoom in here, where am I? Here you can see the grid zone junction labeled properly. The grids all come in properly. This is the map for UTM Zone 15. So the Zone 15 grid is orthogonal because this map is named for UTM Zone 15. It's presented in the UTM Zone 15 projection. And then the adjacent zone grid looks like this. And we've got one for 14 as well. And if we just go in and look at the grid zone designation box, and I'm just going to go real quick and show you. If I go to the grid zone designation box, the different pieces here, this is it. Yeah. So if I just hover over this, what you can see is it's using the value GZ, DGZ. And if I look at the attributes on this, and I actually have to select it. And display the attributes. Is that it? Oh, here. There we go. What you can see is that all of that is done using the text tags. And so there you can see it's a combination of underline, a vertical bar, changing the font size to make a subscript, and so on. So the important thing is that all of that could be done by calculating values from the U.S. National Grid grid reference designation and the appropriate text tags so that way it'll automatically populate that grid zone designation field without having to go in and make a map for every possible different combination of grids of the grid zone designation. So, that was a problem before. You actually had to, there was the one piece that wasn't dynamic was the grid zone designation box, but this was a technique I learned from somebody else that participated in this, and it's really pretty slick. So with that, I'm out of time. Apologize for running over a little bit. I know that was a lot real fast. The most important message is don't start from scratch. Most important message is put grids on the maps that you're already making and make it a UTM grid. And make sure you put in the grid zone designation box. Read that FGDC standard. It'll tell you how to do that. Go download the examples that are out there. I had mentioned that NAPSIG has an ArcGIS Pro project with tasks that'll step you through downloading the data and creating the maps in ArcGIS Pro. I had all the examples and instructions for ArcMap in the MXD. You can download that and play with that. That'll take you through the steps as well. I intend to do that with this ArcMap ArcGIS Pro project. I just haven't done it yet, but if you want it, email me. I'd be happy to package it up and send it to you, and you can start with that as well. And if you have any questions, I'd be happy to hang around afterwards, or feel free to contact me at any time, and we can have a chat. So again, sorry for running over a little bit, but if anybody have any questions for either me or BJ, it sounds like I'm losing my voice. I have to stop talking.
Thanks, everybody.
Thank you, BJ and Randy. I'm going to share my screen.
Okay,
I've
stopped. Go ahead.
Okay. There, I think it's sharing. So yeah, I think Randy said he'll stick around. Well, I'll leave this up for a little bit if people want to type any questions into the chat, and then we can get that out to everyone. So thanks, everyone.
Will this recording be available?
Yes, and it will be, I'm not sure how they're going to get it out, but yeah, it's going to be available on the WLIA site.
Okay, publicly?
I believe so. I'm not entirely sure.
Because we'd certainly like, we've talked about creating videos of some of these presentations.
Yeah.
It's nice to be able to link to them. I mean, I gave a presentation to NISGIC a couple of years ago, and that's out there, and it's real nice on like usngcenter.org and the wiki page to be able to link right to the, I mean, to give a good plug for WLIA as well, if it's publicly available, not just to members, that's what.
Oh, it'll be, oh yes, it will be. Yeah.
Okay.
You'll have access to it. Sure. Yep. Anyone can look at it. Yeah.
Yeah. Well, certainly let us know when it's out there.
Yep. I think everyone will get an email. Anyone who's on the meeting now will get an email about when they're available. I just don't know when that will be.
Yeah, that's fine.
Hey, Randy.
Yeah.
I'm Mike from Oneida County.
Uh-huh.
I had some correspondence with you last year.
Okay.
And if you recall, trying to get you to do this, and I really appreciate you doing it.
Well, it's really nice that it's virtual. I'll tell you what.
Because it's 35 below.
Wouldn't want to be worrying about my car starting,
Yeah, no, but it was a very good presentation, and I know that Adam, the other guy that was on there was only 15, which was a little disappointing, but the Adams from Vilas County, he's our counterpart up here, and we have a lot of lakes and islands and what have you, but something that we're seriously looking at, and I really appreciate you taking the time. And as far as making it available, that would be one way to further engage the community.
Yeah.
With this, because I can really see some advantages here. Standardization is the number one.
Yep.
And I asked that question about the 911 system eventually going to it, and when they go to it, if they go to it, or even included as an option, you know, for E911. I think that'll be huge. The only thing there is the vertical.
Right. We're pursuing NG911 in Minnesota. US National Grid is a part of the NINA standard for your given address location. You do need to provide the US National Grid location. But yeah, vertical is a problem with NG911 in general, and they're trying to figure that one out. You know, you get an XYZ locations, but it's a height above ellipsoid, which doesn't get you to a floor in a building, you know. So that's a problem. And they're trying to NG911 is trying to figure that one out in general.
Who did you work with in Dakota County for the surveyor? Was that Gary Peterson or Gary
Stevenson?
Gary Stevenson?
Yeah.
Oh, really?
Yeah, he hired me.
Oh.
Since retired. He retired about 10 years ago.
Yeah.
So he's living in Florida. He's laughing at us in -35 right now.
Him and I went to New Orleans together when I was president of WSLS. And met up with them, and we had a good time down there. And then I got to know him a little bit more.
Yeah, he's a good guy.
Come to our surveyor stuff.
Yeah, he really brought GIS to Dakota County.
Oh, yes. Yeah, he did a good job there.
Yeah.
And Craig over in Washington County, Hinsman.
Oh, yeah.
Yeah. He's actually was a classmate of mine in Nicolay here in Rhinelander.
Oh, really?
Yep.
Small world, huh?
But anyway, well, thank you very much. Really appreciated it. So.
Well, you're welcome. Nice chatting with you. And then feel free to follow up with me anytime.
Yep. Thanks.